Check, 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 check. Check, 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 check. Check, check, check. Check, 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 check. Check, 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 check. Check, 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 check. Check, 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 check. Check, 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 check. Checky, check, check. Check, check, check. Check, check, check. Check, 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 check. Check, 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 check. Check, 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 choo choo. Do I want to send to 1,000 people? Yeah, fuck them. Give them a notification, you little bitches. Yeah, fuck them. What are they gonna do? Get pinged while they're sleeping? Hell yeah. Okay, okay, okay. Now, let's get my little AirPods. Little AirPods. Gonna listen to some music. Okay. We got this. We got this. And put some AirPods in. Oh, ba-doom. Ba-doom. Okay, and then we'll go. What do we want to listen to? Let's just go all random. That'll do. Actually, this is a good album. Okay, what else do we need to stream? We got Twitch chat. That's not super important. They're easy to automate with AI. You can just make those guys up. They don't have creative thoughts. And yeah, we just need a water. And then we need to go into the gay rage. I think that's all we gotta do. Okay. But I feel like my battery smells quite hot. I don't know why. I don't know if it's supposed to. Hey, S'mores. What you doing? What you doing? You be a good boy? You being a good boy? Yeah. Where you going? You want your beef? Is your beef thawed? We'll get you your beef. Okay, 1 second. Good boy. You know you're a good boy. Don't pretend like you don't think that we know that you're a good boy. You're coping, S'mores. You and I both know that you're the best boy on planet Earth. You're such a good boy. You're so made out of beef. You're made out of cheese. Okay, got that. Let's go get some shoes, S'mores. We need to wear shoes in the garage, okay? Yeah! Oh. Mr. S'mores. Don't lick your lips at me. You want your beef? Let's get your beef. Wow. Beef. You're gonna eat all of this all yourself? I've never seen anyone eat beef as good as you, S'mores. You're so good at eating beef. Wow. Okay. And you fill your Wawa. Yeah, it was a good beef boy. Okay. Water's coming in. Okay. Yeah, you gotta drink all this water. You good, Gumbo? Mr. Gumbo Shrimp? Yup. Yum, 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 yum. Yum, 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 yum. Okay. 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 Let's grab this. Anything else we need, S'mores, or can we go streaming? Okay. 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 What else do we need? A water? Oh, yeah. Good boy. Good boy, Mr. Beefus. The best beef man. Beefy boy! Beef boy! Beef, 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 beef! He's the beef man! Beef man with a beef plan! Beef boy! Beefy boy! Okay. Okay. Let's set up the tripod. Twitch chat's like, oh, it's black. I can't see anything. Well, yeah. I don't have the camera set up yet, okay? Just relax. Streaming stuff isn't easy. I'll have you know, streaming is one of the hardest career paths possible. It's very stressful. You have to be creative. Like, someone had to invent all the streaming categories, even the games. And the streamers did that, okay? And then let's go to twitch.tv/Gamozo. Don't forget to use your Twitch Primes. And I'm signed in. Okay. Let's get. I don't know why my camera smells so hot. The fact that it smells hot even in the garage is a little spoopy because the garage is kind of a stinky place. What the fuck smells? Okay. And then we have the right tripod set up. Hello? Hello? Nice. Okay. Deployed. Oh. Okay. Let's see. I think the camera's working. Is that autofocus working? Let's get the monitor set up. There we go. I think we're good. Chat. There we go. Do we have content? We are blowing out our ISO's asshole. Why is it capping ISO at 640? Why would it do that? What causes that? I'm not familiar with a cap at 640. Did I do that? Did I put a cap on the ISO? I don't know. I mean, 640 is fine, but sometimes we gotta go below that. Does anyone know? Any Twitch chatters? Your mic is burping. My mic is burping. Okay. Let me see. Do you want me to put it to high power transmit mode? I can put it on high power transmit. RF power. RF power. RF power. How do I do this? How do I set my RF power? I forgot how you do this. It's not a normal menu setting. Do I have to hold this? Do I have to hold this? My mic sounds great. God damn it. Here, I can turn the attenuation down. There we go. Hopefully we don't clip. It sounds robotic. Okay, let's see if it stops being robotic. You ready? Is it robotic still? Did we fix it? Ruzzy fuzzy. It's still robotic? Or did that fix it? No change. Okay, that's good. That's good. Okay, let's look at this. What frequency are we on? Okay, good. Output level. Yeah, I don't think there's really anything I can do on that. Okay. Okay, let's try, instead of AAC, let's try something else. How's this? Now we're doing PCM instead of AAC? Is that an improvement? Is that fixed? Solved? Solved? Solved. Better? God damn it. Okay, so yeah, unless it was a drift and it will get bad again, it's possible that there's like a small desync. Wow, okay, that's PCM versus AAC. What about mic levels? I don't think I'm getting too close to peaking here. Okay, oh, maybe I am. Set the attenuator back to 15. So we're hopefully quite a bit quieter. It kind of depends if I'm looking down, but I'm not really going to be looking down at my chest while streaming much. I don't remember how to change the RF power, but I don't think I need it on high power. I'd rather have the battery life, because I find it pretty hard to believe that in this environment anything matters. Okay, levels are good. Now, let me turn my Bluetooth back on, see if it causes any interference. It shouldn't, but it could. I think this Bluetooth boy has been causing some issues because it's screaming at all times at like 50 kilobaud. And a lot of Bluetooth things don't like that. Okay. Okay, now we gotta clean up the floor, because whoever was in here last left a bunch of shit on the floor. Okay, put that there. We can move the vacuum into the vacuum place. Skadoop. Okay. I wonder what causes that PCM versus AAC issue. Why would it be crackling? Is that like a synchronization issue? Is that a codec issue? Like FFmpeg doesn't know how to decode that? To be honest, the NDI stuff can be flaky at times. Okay. And scoop. Okay. We got a vacuum cleaner plugged in. That's good, because we'll probably be vacuuming at some point, which I know is really fun. Okay. S'mores loves to leave aluminum chips near the mill and not use the shop vac, that bastard. Okay, but we're all good now? We can do content? Or do you guys not want content? If you don't want content, just press text no content to 69676. Okay. Bam. I think we're getting ready to cook. Okay, we should probably plug in the camera at some point, but that doesn't sound too important. Might have to turn my AirPods so I can hear myself. Ugh, are they in smart mode? Or they're ducking my audio? I don't want that. I don't want my audio getting ducked. Okay. No, I think we're good. Okay. Are you on PCM or AAC now? I think it's PCM now. What else do we have going on here? Now cam is twitching. I think that's just because there's not enough stuff going on. I was trying to debug that, but that's not something I'm gonna solve for sure. Okay. Wow. It is bright in here. This is 1/160th shutter speed, 800 ISO. Well, it's f2.8. I guess we can, let's change our f stoppage. Can we go fully closed? So let's see. No. Let's do like a f stop. I like keeping my ISO like under 3K. I don't think it matters that much. Okay, f 8.0. How do I turn that on so it has notches? Click on. There we go. Now we're clicked into that. Okay, so now we should have better depth. And ISO's happy. We're at 1/60th, are we good? Yeah, I don't know why it's twitching on the bottom. That's some NDI bullshit. That's something for chat. Okay, let's put our collets away so we don't have collets on the floor. And then I think we're ready to party, chat. Is everyone being a good boy? Okay. So, I guess I need to plug in the camera. So needy, chat. So needy. Okay. What extension cord do we want to use today? This one? This one looks short-ish. I don't want a big one. Swoop. Swoop. Okay. All right, and then let's plug it in a spot that won't kill us if we trip over it. Let's go here. Plug that in. Plug in this. We are ready, chat. We are ready. That's in. Plug it into the battery pack charger. And we are ready. Okay. Huh? If you stream more often, you might not have to fix your camera as much every stream. I don't know. This camera, this is kind of the first time it just worked when I plugged it in. Normally it does not. Normally when I plug this camera in, it just doesn't work. And usually I need to do a firmware update and an OBS update and an NDI update, and NDI has switched what FFmpeg version they use, but the FFmpeg version is outdated, so I have to go get an old legacy one off the Gentoo and then install it as a separate package, and then the paths are wrong, and then I have to figure out the new library paths for the old version of FFmpeg. It's not a great experience. NDI, I don't understand how NDI can they basically are a specification They make like the standard, and their standard implementation, the reference implementation, sucks ass. I don't like it. I'm mad. I'm very, very mad. Let's see. The camera isn't very level. Okay. That should be more level. Okay. All right. And my scale. I think it's inside. I'll go get my scale. Hi, Bungus. Is that where you're gonna nap tonight? Yeah, you fix your popsicle? Okay. I trust you. Yeah. You are a good boy. You know that. You know that you're a good boy. Don't you? Yeah. That's because you're made out of beef. Okay. Back in a bit, Bubble. I gotta go entertain chatters. Yeah. Yeah, they're not even using their Prime subs. Yep. No, that's okay, S'mores. Doesn't us. Okay. Now it's lagging. Jesus Christ. You gotta make up your minds, chat. Is it working or is it bad? I think it needs motion, weirdly. It seems to be really unhappy without motion. Okay. Let's get our scale leveled so we can do some weighing. Okay. Boop, boop, boop. I'm not the best at leveling scales. Forget what leg I'm adjusting and in what direction. I don't know why. Just needs more practice. That's probably good enough. What's up? Came for the fuzzing videos, staying for the screens. Hell yeah. This way? This way. Okay. We'll calibrate that. Why is my video teleporting? Okay, like working. Just trying to wait for the scale to blow on it too much. Network issues? Doubt it. Oh, wait, we got low Wi-Fi reception. Because I think I have my access point garage plugged in. Is this plugged in? I think it ripped out, maybe. It's got warmth. I think my yeah. I 1 bar of Wi-Fi. Chat. Can you tell me my Wi-Fi password? And God, this. Okay, that looks good. What's this? Another ampersand? Okay. Please. Please connect. Connect? We good? Hello? Hello? Are we good? We've got so many bars now. I don't even know how it connected to that. Okay. Okay, is it fixed? Are we good? Do we have infinite quality now? Because I've got full bars. We got full bars there. We good? We're good? Seems okay. Yeah, it had terrible reception. I think it was connected to my outdoor unit and not my garage one. But yeah, now I've got max bars. So anything at this point is a software problem. Okay. How's our scale looking? Scale's looking good. Okay, chat. Is everyone excited? Because today we're going to make some screws. Yeah. Yeah, let me turn this around so I can see what I'm doing. Flip this up this way. And we'll go for a little zoom in. Yeah, that should work. Maybe a little over. There we go. And a little up. Now we're cooking. What size and pitch? Well, we're going to be using a die because I don't have any other way, and now I'm sitting on my mic pack. Hopefully I didn't mute myself. No, I don't think I did. I think we're good. Okay, so we need to make screws for these little holders. So these are, and I wonder if it's going to focus well on these. So these are little round insert holders for my fly cutter that I've made. So, and I should have 4 of them. And basically all of these need to weigh the same amount. Technically they need to weigh the same amount when they're loaded with an insert, because I want to be able to spin this, this fly cutter up to pretty high speeds. So yeah, it is focusing on those. Look at that. How's the camera quality? Is it good? Good camera quality? Yeah, I don't know how, it's somehow connected to an old Wi-Fi access point, which makes no sense because all of them should propagate. Okay, so hopefully those are pretty close. What I've basically done is, after the fact, I don't know if it will show up on camera, but inside these, inside the blind threaded holes, I kind of just cut out more material. I think it was in there, where I kind of cut out more material until I got them to weigh the same. So let's see. It's been a while since I've done this, and now they have like just kind of dust on them, but they should be roughly fine. They don't need to be perfect. So we got 9281 on that one. 9282 on that one. 9283 on that one. And 9281 on that one. So that is actually quite good. We're within about on all of these. Yeah, which this scale is very sensitive, right? 0.01 grams. I mean, it's not the most sensitive you can go, but at these masses, it's actually quite a sensitive scale. Just blowing on this will throw it off, or it being out of level, right? If I tip this up, it reads off by a gram, right? So it's really important for scales like this to get them level, which is wild. And you also kind of want the shields around them. You can see how long it took to kind of balance in there. So anyways, we need to make matching screws for these that are also weight balanced. So we can either balance the whole assembly, but I'd rather balance the individual pieces such that we can go in and just swap them between, right? So these are kind of individual units that go into the fly cutter. So I'm actually very happy that those have held their weight and haven't drifted much. So here's the fly cutter. It is big. It's 12 inches in diameter and I think 3/4 of an inch thick. So, and right now it's mounted on its arbor, but effectively these inserts go in the holes, right? So these are nice reamed holes. We go in there and then these sit about 2 millimeters shallow of that top surface. So all I need to do is make a screw that goes on this side, goes into that hole, and then just butts up against the surface. So should be quite easy. We'll be doing this on the mill because, once again, we don't have a lathe running. But I'm quite happy with the fitment, and I can kind of adjust where I put these. And everything's been working quite well here. So I actually really like this. And I've been able to spin this up to, I think I spun it up to like 3,000 RPM without inserts. And originally I had one insert made, and just having one insert in here throws off the balance so much it's unusable, right? Like even at 500 RPM, it is pretty unstable. And that's why I have all 4 of these, and it's why I switched to, did this whole pattern. Instead of doing a standard, adjustable, where you can adjust it, I wanted to kind of have this mass, and the goal is to get, a really, really good finish right off the mill, so I can go right from milling passes straight to scraping or lapping. So I really, really, really want this to give a clean finish. And for aluminum, that requires speed, and I do a lot of aluminum, of course. So I think these are made out of 316 stainless. It's just kind of what I had. And I forget the size that all these threads are. So we'll have to measure those. And then basically we just have to make little screws. And we'll just make a slotted screw because it's easier to make. I think this was playing around with it. But I didn't realize how sensitive dies are. Dies really like to thread at an angle. And I didn't really know that, so I didn't have this in a rigid fixture that really kept that aligned. So this is kind of just a trash piece, but this was kind of just a test. So obviously we won't be using that. And then I have just some extra cutoffs. This is probably when I was making some of these holders, and I probably just fucked up, and these are probably just off by a little bit, so I scrapped them. So we could potentially make the screws out of that. I'm not 100% sure yet, otherwise we can go get fresh stock. They're just kind of leftover pieces of metal. But they are 316, so machining this sucks ass. But yeah. We can see dirtiness on this plate. Yeah, this plate is quite dirty. You can see that this hole right here, I gave it a little polish to. Just to see how well this polishes up, and it actually polishes up quite well. There's a small lip on these where I went in with that radius, because everything in here has a radius machined on it, which is actually quite a difficult operation, and you can see that there's a burr in some of these holes. So I was using this this pencil grinder. This is before I got my new air compressor, and going through and kind of cleaning up all these holes by just polishing them. But the burr is kind of still there, so I think I'm actually gonna go in there, and I have some like flexible sanding things that I think will be able to take that burr off. So these are reamed holes, but the burr is really only on the top and bottom, so I'm hoping that I can just touch kind of and blend in those surfaces where I did that radius, but not really touch the inside. And then we'll go in there and polish it up, and really we're just trying to decrease that surface roughness so we just have a slightly smoother fit. Because it's a very tight fit. We have a reamed finish against kind of this effectively turned finish on here. And I think these are quite tight tolerance. I can't remember how accurate I got them to hit. So yeah, let me go get my thread checkers and see what thread these are. I think they're N8. And what else do we need? So we'll kind of start there. It's really going to be whatever I have a die of, because I guess I actually have a lot of die. I didn't realize that. Okay, I haven't really used die often, and they're kind of tricky, and I'm working with stainless, which is already kind of a bitch. And then let's the mic just unlocked. Okay. Yeah, the mic unlocked. I think that means I just didn't have it locked, or somehow it was able to actuate the lock in my pocket. So we'll keep an eye on that. Okay, anyways, we got the micrometer set up. What have we missed? Probably not too much. So let's see what dimensions. So I pretty much do everything in metric. I think this is 20 millimeters is what these are. Whoop, 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 whoop. Okay. I imagine they're 20. They look like a 20, and it's probably, yep, 19986, 19987, 19985, concentricity, 19987. Yeah, I'm not like super happy with how these turned out, but they turned out fine. I mean, once again, it doesn't matter. 19979, that's probably one of the worst ones. Guess we want under on a lot of these. Well, I guess they're going in a hole, so under makes sense. Here's a 19996. Okay, this one's gonna be one of the tighter ones, but I think it should go in there. And then these holes on the fly cutter are reamed. So those are already going to be slightly oversized. 19,999. So yeah, 2 of these are kind of shit, but I think I just gave up and I wasn't going to make more of them. And then I imagine it's 25 millimeters on the outside diameter. And the tolerances don't really matter here too much. Yep, 25. So we've got 25 mil, and then we've got 20 mil for the actual holes. And then the threads, I think, are M8. So, let's see. Unless they're M10. No, they're M8. M8 125, just standard. Yep, they're M8 125. So, perfect. So those have been tapped. Didn't go for a huge amount of thread engagement, but I think we should be good here. We might have to be careful to make sure that we have the correct thread sizing on the parts that we dye. But dyes are much more forgiving to that. These blind holes are just kind of hard in stainless. Okay, so really we just need to make those screws. And I think what we'll do is, let's see how deep these holes are. I can't remember. I don't think I've modeled any of this stuff. I think all of this has been kind of just been done. That one's a 14 mil deep. This one's 14, 16. That one probably has a little bit more drilled out to balance. 14. So I think if those are 14 deep, then we're going to go for probably 10 millimeters. I think 10 millimeters will be totally fine. I imagine that's roughly what I did on these test pieces. That one I did looks like a 12, and then, yeah, I think 10. So we'll go for 10 millimeters deep, will be the plan there. And what's the OD of an M8? This is a 7.81, 7.8, 7.8, 7.82. So we can go for like a, let's go for a 7.82 is what we'll do. Let's get our handy dandy notebook out. But yeah, what's Jack been up to? You guys haven't been following any of the streams. The first stream you guys were showing up to. Okay, so we want an M8 by 1.25 by 10. And the shape, just draw kind of the cross section. Got a little cap here. And then we'll go 10 deep. So we'll say that the diameter, what did I say, like 7.82? 7.82 should be good. At least that's what this thread checker is, which is fine. Maybe a 7.84 if we want to go for like a little bit more thread engagement. Let's say 7.84. And let's just say this is an under. 7.84, we'll say 10 millimeters deep. And then the head, how thick do we want the head to be? This one is 8. That's gone. I think 8's a little thick. A little thicker than I want. I have no idea where that went. That is gone. I think we might do a 5 millimeters thick on the head. How does that sound, chat? Is 5 too thin? 5 should be good. Let's do 5 millimeters on the head. 5 millimeters. So we'll do 15 millimeters for the whole part. And then for diameter, how big are these holes here? They should be 20, but with a little bit of that radius. I think we can go with the 25 millimeter. So we'll do a 25 millimeter head. And then we'll figure out what we want to do for slotting those. Probably as the last step. No freedom units. Yeah, it's tragic. Okay. 25 mil on the top, 5 millimeter head height, 10 millimeter threads, and then we'll go to 7.84 on those. And we really just need a way of holding them. We do have a decent amount of material to remove. Let's see if this is already machined to 25. This is a 2479. That's already botched. It's fucking trash. This one looks undone, so this one we could use. And we're 35 tall. Oh, is that not enough? I mean, we can go... I think what we might do... I think we might take our 25.4 and we might just take that down to 25 mil. How big of that will be stick out? So we need a little bit of kerf for the cuts between them, which is probably like 2 or 3 millimeters. So let's say these are 15 millimeters a piece, and then we need to make 4 of them, and let's just say like 4 millimeters for kerf, which should be plenty to saw them. So let's say 19 mil times 4, 76 mil with a 25.4 diameter. So we have like a 3x ratio for stick out. I think that will be okay. I think that'll be okay. Unless we want to do this in different cuts. I'm a little afraid of deflection, but I think it should be okay. Are we scared, chat? I don't think we are. I think we can do all that. We'll just grab a piece of 316, and I'll go put these pieces away so we don't get confused. And we're gonna cut that off to, what did I say, 76, plus let's give it an inch of engagement inside the actual collet. So let's just cut off a piece of 316 and we'll make it 100 mil long. I think we'll be okay. I think we'll be okay. There will be some deflection, but this isn't the most critical dimension, okay, chat? Like, relax. We're doing this because it will look cool. And then let's go find, where is my 316? I think this is my 1 inch. 1 inch diameter 316. That looks good. Let's cut off at a random angle. And let's just see. Let's make sure this is correct. So we're at, yep, 25.38. So we can use this, and then we'll cut that off to 1 inch. So let's get this ladder moved out of the way. Boop. And we'll measure out 100 mil. How's that sound, chat? Yeah. Shoo-ba-da-ba-da. Okay. You should get the German table Allen book. What's that? Okay. And then let's see if that's gonna hold in there balanced. And we'll measure 100 mil. Definitely gonna be a little bit of stick out. Oh, I'm actually gonna be curious how much taper we get off this. Go. I guess 107's a little overshot, but that's okay. 102. Just mark it there. Good enough. part of this is just gonna go in the collet, and then we're gonna kind of finish it off, and then we'll kind of make the parts one at a time. This is heavier than I think. Let's get this in roughly the right spot. Okay. Hopefully this blade's in good shape, because it is stainless, and it's pretty thick. But this blade should be fine. All right, I'll let that cook. It's a common requirement for students in Germany who do metal stuff. I think it's called mechanical and metal trades in English. Interesting. Does that cover like welding and stuff too? Okay. So we need a M8125 die. Really, we're just going to be turning down to the right diameter. So we'll turn everything down to 25, and then we'll try and stick it into the collet as much as we can, and then do the M8, because the M8s are where that tool force can really have a lot of bending. Okay, let's see. Where are my dies at? M20. M20 is the M8 out somewhere. M14. M6. M8 125. There we go. Okay, so we have the die. Cut's going good. Okay, so we've got a high-speed steel die. This is what we're going to use to cut the threads. But none of that really matters until we actually make the profiles for these. So we're going to be lathing on a mill. So you're going to see one of the skills that I've acquired. And we want, where's our 26? 26, 29, 28, 20. I think 26 is out somewhere. Uh-oh. Oh, I think it's in the vise. The Son and the Spirit. Okay. I might not have enough pressure on that blade, but I think that blade's starting to get a little old, especially for stainless. Okay. And we'll grab this. Kind of getting the mill ready. Yeah. How's the cut? Good? Boy, that's going pretty slow, chat. Okay. Put this up there. Put this in the hidey hole. Okay. Okay. Yeet. Okay. Yeah, I'm curious how much deflection we'll have. I'm definitely not great at using dies. As you've heard, I think I've used them like twice. They are more finicky. They're not very prone to breaking, since they're external, unlike a tap. So at least we probably won't have to worry about breakage. Hope not. So I'm getting my ER40 ready for this task. And how deep does this bore go? I should have measured that before we did that. Okay, cut's complete. That's good. This tool holder goes 32 mil deep. Perfect. So here's what I'm setting up. This is a ER40 tool holder. So this is where you'd normally hold an end mill, something like that, and then R8 shank, so it goes into my bridge port. But we're actually going to be lathing on a mill, so we're going to be stuffing this in, and we're actually going to be holding the work in our milling machine, and then we'll use lathe tools to take off those cuts. So that sounds fun, chat? So we'll deburr this part quick, and then once that's deburred, we'll be able to load it up. So we got to get rid of that burr, otherwise it's not going to sit correctly in that tool holder. So the way that I deburr for something like this where it's not critical, you can see just from the cut here, this pretty big burr. And that burr obviously is going to prevent us from clamping onto this nice and uniform. And same thing over here, you can see there's a little bit of an angle on that side. I think this side is better. I've gotten a lot better at using the bandsaw. I think when I initially got it, I had a lot of issues with it not cutting straight. So all we're gonna do is we're just gonna put a small chamfer on this on the grinder. It's just kind of the easiest way to deburr that. And that's good. We don't really care about a burr on the end. We just want to make sure that radially it will go smoothly into there. So get that deburred. It's a little hot where I'm holding it. Okay, that looks good, feels good. So now we've just kind of knocked down those edges a bit, and it'll go a lot better into that tool holder. So we can either true up this side that's at an angle, or we can just ignore it. And I think we'll just ignore it, and we'll use the cleaner cut that we just made. So here we can drop it into the tool holder. Let's get it approximately tight, but not actually tight yet. Just so we're a little closer. Okay, that feels pretty good. So now we need to make sure that we have 100 millimeters of stick out, because we're gonna have, or wait, not 100. What did we say? We said 15 mil per plus 3 for kerf. Let me see what my blade is in this right now. It's a 1.22. I think we can hit 3 mil cope. So let's say, yeah, 15 plus 3, that's 18. And then we need to make 4 screws, so we need 72. So let's try and get, we could probably expose like 75 mil here. And, okay. Okay. So we're just kind of adjusting this, getting the right amount of material stick out here. I don't think we'll have any deflection issues. We'll say 75. 75 is bigger than 72, so that should be good. Then we don't have to work all the way up to the chuck here. Kind of just eyeballing this stick out. That looks pretty good. Let's lock it down. Okay. And let's double check that. So let's just see roughly where we're at here. 75, 74, 0.9, 75, I'm measuring a burr there. 75, we're totally good. Okay, we nailed it. Why manual machining? Because manual machining is way more fun. CNC is just not very fun. Okay, now let's tighten this down. Oops, undid the wrong thing. Okay, so I've got a ER or an R8 socket here that I made, I really need to mount this permanently to my table. Right now, I just have to put this in a vise, but it's a piece of hex block. Look at this bad boy. This is something that I made like, I don't know, maybe 6 months ago. But it's just an R8 approximately, and with a key in there, and that key indexes on that set screw slot in R8s, which just with a set screw is not enough, but since this key goes the whole way, it has plenty of engagement to hold that collet nice and still, so I can actually torque it to a correct torque spec. So this just slides in here, seats in there nice, and this is how I make sure that I kind of torque all of my things the same. So I have this set to 130 foot-pounds, which is 176 Newton meters. And we'll just tighten this down, which is quite a lot of force. There we go. Okay, so it's really important for ER collets to actually clamp them to the correct clamping force for them to hit their tolerances. Now, my ER40 collets are kind of cheap and shitty because I use it to hold parts like this, but my ER16 and ER32 collets are quite nice, and yeah, it's quite important to hit those torque specs correctly. So now we're gonna just load that up in the mill. Oops. Should be good. Let's make sure we have room. Let's run the one-shot oil. And we should be good. And we're just gonna load this up. Okay, nice. I've been doing a lot of construction in the garage, so I haven't used the mill in a while. So next thing we're gonna do is just first clean everything off. Cover your ears, chat. Okay, did everyone wear your hearing protection? And then we'll set this up. I have the rotary table in here. I'm not gonna remove it for this task. So we'll just do everything right on the rotary table. So I'm gonna use this insert. Don't know what insert it is. It's some sort of a diamond insert. It is designed specifically for stainless. And we'll raise that up a little bit. Let me go get some parallels. I don't have the right size parallels for this vise, but that's okay. We'll just whack these in here. And this is a precision vise. Like, this is gonna be a little bit annoying to adjust compared to a normal vise. Just the way that these kind of work. Come on. There we go. Okay. But once we get it locked in, it won't be too bad. Looks like we might get lucky here. It kind of depends on where those threads fall in. And then we've got those two parallels in there. We'll have them hang out mainly on this side. Once again, accuracy does not matter because this is basically just holding a lathe tool. And then we'll clamp it down. We'll make sure we get good clamping on this, and there we go. Now we've built a lathe. See? That's not hard. Do AirPods count as hearing protection? Yeah, they do. And ultra high precision CNC is $1 billion. I haven't really looked into it. The only thing I know is like people meme about the different brands. Hey Metaconstruct, how's it going? Okay, so am I getting you in close enough here, chat? I think so. And I don't know what side of the mill I'm going to be working on today. So let's first just make sure everything's looking good here. Move this down a little bit. I don't like milling at the extremes of my quill because that can kind of engage on that power drawbar a bit. So really we're just going down, we're removing material, but we can't really know how much we're removing until we remove something. So let's first get our tools centered up. And I think just eyeballing center here is gonna be fine. So let's see. I'm gonna be mainly working from this side. So let's see where I can get the camera into. I have rubber mats on the floor, and they're kind of gonna interfere with the tripod, so let's scoot them. Let's see if we can get you a good shot. I'm gonna unplug the camera here. Chat, remind me to plug the camera back in. I mean, technically for a cut, we probably don't have to. And I really want to get you guys in on the tool. But I also don't want you guys to interfere with where I am. Okay. And then let's see. Are we going to need manual focus on a shot like this? I don't know. Okay. That looks good. So I need to find center on that, and then we'll calculate our feeds and speeds. I completely forget what these inserts are. I'll probably pull up the specs on McMaster. I think that shot actually looks pretty good. Big chillin'. Hell yeah. Let's see if I'm logged into McMaster on this computer. I really hope I am. Nope, I'm not. Damn it. Do I know my password? Nope. Nope. Fuck. Log on with a one-time code? Fuck yeah, I can do that. I can do that. Oh, I have 2 steps, so I can't do that. Haha, XD. Fuck. Where are my passwords, chat? Does anyone here know my password? Have you watched Cutting Edge Engineering? Yeah, I've watched a lot of his stuff. I've fallen behind on a lot of his videos because I don't want to watch his videos unless I'm like paying attention. In reality, I should just put him on more because he puts out them consistently enough that I'm like not prepared enough to watch them. Okay, McMaster. Okay, log in. Okay, then we get our 2 steps. Sometimes the McMaster 2-step takes so fucking long to show up. I've waited like 15 minutes for it before. Really annoying. I wish they used like a 2-factor app thing, but they send it to your email and they have one of the slowest servers. I don't know what their backend is for this, but it's awful. But yeah, I love Cutting Edge Engineering. Okay, looks like I got it. I'm logged in. Order history. These would be inserts. Insert. Inserts. Lathe tool inserts. Stainless? I think this is the right one. DCN T3251. That one doesn't have the coding. But I think it's the correct one. They might just have a different photo. I don't know. It'll be good enough. What speed does it say? 750 to 990 surface feet per minute. Which is, let me get my, what is it, 0.3048? Is that the scale? Is that the conversion metric? I made a little cheat sheet that has my conversions. Feet per minute times 0.3048, which is the number of feet in a meter, I think, is all that is. Let's just say 750 times 0.3048. That's 228 meters a minute. That's 228,000 millimeters a minute. Pi, what's the diameter of our part? 25.4 times pi, divide those two. Does that really want 2,800 RPM? Holy shit, that seems so fast. Am I crazy? 750 surface feet per minute times 0.3048. That's 228 times 1,000. Pi times 25.4. Yeah, that one's 2,800 RPM. Oh my god, chat, we're gonna send it, but man, that seems so fast. And then I'm just gonna make a note of that. DCMT on this sheet. We'll say DCMT 316. It was 750. So this is 228 meters per minute. Okay, so that's 2,800 RPM for this cut. That seems so fast. Fuck. Okay, and then how fast does that mean we want to go through our part here? We could do like a 0.05, like a 0.05 millimeters per rev. So like 2 thou per. That's 143 millimeters a minute. That's pretty conservative. Let's see how this works out, chat. So first, let's try and get all centered up on our part. I also think I'm out of coolant right now. Oh, wait, let's make sure we clear. I think we do, just barely. Uh-oh. Uh-oh. My switch is getting tripped. Okay. Oh my god, we're so close to not clearing. Let's just raise this up. Raise the tool up just a little bit more. Unfortunately, I just want a little bit more clearance. Oh, man, this fucking limit switch. I need to fix this. There's a limit switch for my Z-axis traversal that is clearly getting tripped up on where these two aluminum channels right here. This is the Z-axis power feed limit switch here, this black thing with the yellow label on it, which somehow I cannot get in frame. There we go. This is getting caught up on some, oh, look at a screw. Trash. Okay, why is that getting bound up? Is that screw loose? Did these bend? Because if I take the cover off, it's fine. Did I put the cover on backwards? No, I don't think so. I mean, I can put it on backwards, and maybe that helps. The springs went flying. But we might just do that. That might be the fix, chat, okay? Next, let's see if we have coolant. We have none, okay? So we gotta load up the coolant, because we're gonna want coolant. Aluminum is kind of, or not aluminum, 316 is kind of interesting. I think you can run it dry. I think a lot of things recommend running it dry. I'm just always afraid of getting too hot. So, okay, I need to move you guys out of here. But we gotta cook up a new batch of coolant because that is bone dry. So let's see where my cool mist is at. I think I put it in storage. And I should find those springs before I forget, wherever they went. I see one. Can I see another? I hope it didn't go under the mill. Found one. I do not see the other spring yet. Okay. Okay. We'll just remember that at some point, you know? Definitely won't forget that that spring got yeeted. Now, let's find our coolant. Did I store it? Did I store it? I've been kind of reorganizing the shop. There it is. Been reorganizing the shop, so I don't always know where everything's at. I think this one's 32-1, 4 fluid ounce with 1 gallon water. Is that 32-1? I think it is. And I just eyeball it. Pour some of this in there. That looks good. And then we'll fill it to the brim with water. Okay. Got a small bucket. Now, luckily, I have added water to my garage, so I now have a water source. Cleaning out this bucket because it had dust in it. Sorry, probably got blasted. I didn't plug in the camera because chat didn't remind me to plug in the camera. But yeah, I can actually fill up a bucket of water in the garage now. So here we go. Here we go. I need to put a hose on this because it's kind of splashing all over the place. It is the highest pressure point in the house. Yeah, this sucks ass. Definitely need to put a hose on this because it's just blasting it's blasting kind of a mist of water everywhere. Okay, hopefully we got enough. Kind of nailed it. Kind of nailed it, chat. But yeah, I need to put some sort of a hose on there so it comes out more laminar. It's just coming out as just kind of a mist. Not a mist, but a high pressure mist. Okay, let's plug in, chat, because no one reminded me. There we go. You're charging. Okay, did we do everything now? I haven't used the misting setup yet. Oh, wait, we were adjusting this. Okay. We're just raising this tool up just a bit more. These are 22 mil, so we're gonna go up 25 mil. Starting to not have the best amount of engagement on holding the tool, but I think it's gonna be fine. Okay? It's gonna be fine, chat. But we're gonna gain a few millimeters here. Okay. Scoop. Tighten down the vise. And then let's center it up. I'm gonna center it up by eyeball. That should be probably good enough. But we'll see. We might have to adjust where that's cutting. And finally, let's make sure we have good clearance. We do. We're gonna call this 0 for Z. And then I wanted 143 millimeters a minute. So let's get that tuned in. So we're running 350. There's 140. Yeah, that should be good. Okay, let's go up to 0. double check. We are good. DRO's being good. Okay. And we'll touch off. Let's just give it a little boop. See where it is. Okay, we'll call that 0. Okay. I think we're pretty much there, chat. Okay. We've built a lathe. Let's get the camera better. Okay. Okay. Is that a camera? Let's make sure our coolant is working. Come on. There we go. There we go. Okay. And then we've determined our 0. Are we good? We ready? Locked in there. Let's turn it up. Let's make sure nothing explodes. We want it 2,800 RPM. God, that seems so fast. How's she sounding? Okay. Is that misting enough? I think so. Okay, let's go and take a tiny ass cut. Let's see what happens. So, we're just gonna take off 0.05. Shift it down. Let's see what we get. Oh baby, that's looking pretty good. Oh, I need to mount this on the right spot. But yeah, we're getting pretty good chips. I'm happy with this. Nice! Nice! Lathing on a mill, chat. Lathing on a mill! Got a little hot. I can smell it. And then we'll get the coolant on the actual table now, so it moves with the part. Okay. Okay. There we go. All right, let's see. This got too hot? Nope. Okay, we're actually good on heat then. All right, let's see where we are. We'll call this 0 for X. Man, that actually is pretty good, chat. That is pretty good. So, pretty happy with that. Let's see how far we are. Oops. We are at 25,268. I don't know if I can get this on camera, can I? It's gonna be tough. 25,26. I don't know if that was a good reading. It's really hard to do this on camera. I'm just gonna do it myself. Sorry, chat. 25,258. 25,248 at the top and the bottom. 25,275. 25,252. 25,252. And then we'll go to, we want to go to 25, which means that's 252, that's 126 to advance into the part. 0.126. So we'll go 0.12, and then we'll call that, and then we'll do another pass, hopefully. Or is that too big of a cut, chat? No, we're fine. We can do it, chat. I ain't scared. I ain't scared, chat. Okay. Coolant running. Coolant looks good. All right, here we go. Here we go. We want to go to 1. I'm getting scared, chat. Let's go to 115. 115. 116. Sending it. You don't want to dwell on stainless. I think we want a little bit more speed. Let's go to 180. There we go. We're getting one kind of continuous chip there. It's making a mess. But I like this. Stainless likes to be cut. You need to remove material from stainless. You can't just sit there AFK. Okay, there we go. Happy with that. Let's see, is the part too hot? The part is not hot, which is good. For stainless, you don't want the part to get hot. If the part's getting hot, you're not removing enough material. So, let's see if we botched the part. So, in theory, I'm at 0.116. So, 25.252 is where we were. I did a 0.1161 removal. Double that. Subtract that. We should be at 25.0198 at the top. And we're at 25.027. Not bad. 25.034. 25.050. And 25.063. So now we can get in here and we can do our slow ass gentle cut. So let's go 25.028. 25.028. Subtract 25, divide that by 2, so we'll go in 0.014 millimeters. So let's reset that. That's now our new 0. Okay, let's make sure we're on the right lash. And we're good. And go up to 0. There we go. There we go, chat. Get our coolant on. And then for this one, I think we're just gonna finish it up on this cut. I'm gonna slow down the speed a bit. Let's see what speed we're at. I'm gonna go down to 0.9, or to 90 millimeters a minute, which is quite slow. But I want to get the best finish on here. And with stainless, this could fuck us. Because remember, stainless likes being removed, chat. Okay, we're gonna take off 0.014. Did we do that right, chat? I think we did. 0.014. Okay, we're going in. Oh, overshot. That's okay. 0.0. See, this is going to be a hard one to hit. 0.0147. 0.0147. This is going to be a really light pass, really slow. 0.0147. There we go. Oh, baby. She's looking good. She's looking good, chat. Look at that. You like that? You like that? Not looking good, chat? Oh yeah, super light pass. Let's re-zero this, just in case we have to do another cut. So it looks like it's cutting a little wider at the bottom due to that deflection. Or something, I don't know. That's how it works. But yeah, that's looking pretty good right off the machine. And by the machine, I mean lathe. And I expect this one might be a little warm. Nope. It's not. That looks pretty good, chat. That looks pretty good. Lathing on a mill. Okay, let's see what we got. Are you ready? We fucked it, chat. We fucked it. 24981. We completely botched the part. 25.000. That's pretty good. I like that. Okay. So the top is fucked. Oh, wait. No, it's fucked. 24981. In the center, we're at 24999. And at the end, 25007. Okay, it's fucked. The part's scrapped, chat. Okay. So now we have kind of our raw piece. Let's blow it off, get this coolant out of here. Okay. So, that turned out pretty good. I'm happy with that. So, next thing we need to do is turn that down to the small dimension, which is going to be a lot more material removal. To the trash. Yeah, isn't that pretty good, chat? Lathing on a mill. That ain't too bad, is it? Especially with that amount of stick out. That's a decent amount of stick out. So, we're getting some nice precision screws here. So I think we take this out, and because this is going to be probably too much stick out for us to cut down, because we need to cut this down to, we need to make 10 millimeters. That's like 7.84 millimeters in diameter. Which is a lot of material to remove, chat. And I kind of don't want this much stick out, but I can't stuff this in, because I don't think my R8s go to 25. Yeah, they go to 20. So this is the only way I can hold material this big in my mill. So, how do we want to do this? Or do we just want to go for it and see how it is? Because this should be maybe pretty sturdy. We're only gonna be operating on kind of the end, but it's just a lot more stick out than you want to have. But the problem is I now have two different diameters. I have the original diameter inside this collet, and then I have this new diameter, which is that 25. So also, we're gonna switch from the micrometer to calipers, because this does not need micrometers. I'm sorry, chat. This is not a precision project. 2502, 2496, 2496. Okay, we are good to go. So, yeah, I mean, we can just kind of see what happens. So I think the first thing we want to do is just face off this bottom part. Once that's faced off, that will set our, that'll set our y-axis, and then we just want to go to 10 millimeters, and then just start removing a fuck ton of material over and over and over again. And that we'll want to be doing, we'll basically want to be optimizing for material removal. We might go through this insert, because this is kind of the right insert for this, because we have to get under the head of the screw. So the screw's in here. We're going to be making basically the threaded part right now. So fuck it. Let's just, let's approximately find a 0. So we actually have 0 now. I'm going to go to another coordinate system and just 0 that out to save where we are in X so we don't lose it. And then we'll offset a little bit here. And then I just want to try to find a good 0 point here. We'll remove a little bit material just to face it off. Okay, roughly there. This is kind of touching off. We'll 0 both. Go down, over. We'll go up, and we'll just remove. We'll remove fucking 0.1 mil. This one we don't have to double. Don't really need to lock the knee here. And then let's just do the same thing. This is just a facing cut. And then in theory, we need to adjust our speeds as we do this cut. Oh, let's also make sure we're not flying on this, which we are. Because we want to cut at that like 150 mark. Is probably what we want. So let's see, this should face off that end. Not enough. Let's remove a little bit more. Let's go to point 2. Just trying to remove that, get a nice flat surface so we have a y-axis reference. I want to remove it a little more, actually. I think that is touching everything. That looks good. Okay, so we've now cleaned up the bottom of this part. This is now the tip. So we can now say that's 0. Yeah. Yep, all of that is touched. Oh, that's actually a really nice finish on that 150. I think that is the same we're going to be doing for our down. We're going to set that to 150. Okay, so now we go up to, let's just go up to point, or we can just go to 10, right? We can just go to 10. Or we can undershoot 10. I think we should undershoot 10, and then at the very end, just give it a little kiss. So let's say 995. Okay, and then, yeah, we're just gonna be removing material. We should be at, how deep do we wanna cut, chat? How many passes do we need to make? Because we need to go, oof. How many passes, chat? I gotta change up my music. What are we thinking, chat? What are we thinking? Let's see if McMaster had a cut depth, cutting edge length. Cutting depth, 4 thou to 79 thou. So 79 thou. That's like 2 mil? 2 mil per pass? Holy shit, that's deep. We're not gonna do that. We'll maybe work up to 1 mil? How many passes do we need to do? We're going from 25. So 25, and then we want to go all the way down from 25 to 7.84. which is 17.16 millimeters diameter removed, which is 8.58 radius removed. That's actually not too bad. 8 passes if we can go a mil deep. That's a little deep for this stick out, so I think we're not going to. So let's make sure you got good coolant. We're gonna have a little bit of deflection here, so we'll just have to do a gentle final pass, okay? And then remember, chat, 9.95 is our Z setting. Okay? You remember that, chat? 9.95 for our Z? Okay. Okay. So getting into this part is gonna suck. Yeah, that's a lot of chatter. Just send it 0.5 down. Clean. That's a great chip. Okay, it loves that. It loved that. Look at these chips. These are beautiful, chat. Look at these chips. That's a good chip. That's a clean-ass chip. Okay. That went great. Nice. Okay. Fuck yeah. Okay, same thing. We're gonna go to 9.95. Don't have to be too precise. And now we just want to remove material. And now we're going to 1. Here, let's try a 1 mil cut. Down. Down. All right. She can do a mil. She can do a mil at a time. Fuck yeah. Okay. Okay, so now we're at 1.5 there. Fuck yeah. We're so good, chat. We're so fucking good. Okay, 9.95. And the cap is 8.58. Okay, okay. Where are we going? We're going to 2.5? And then we gotta go down right away. I'm just kind of making sure I'm ready. Here we go. 2.5, down! Woo! Easy. Easy. Beautiful, beautiful. Okay, now we're doing ops. Now we're doing fucking ops, chat. You really just gotta figure out what's working, what's comfortable. Okay. That was 2.5? Yep. Going to 3.5. 3.5 and down. Good. Good, 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 good. Chips are getting a little hot. Okay. That was 3.5. We're going 4.5. We might want to decrease our depth of cut here pretty soon. Down. Beautiful chip. Wow. That's cutting great, chat. Okay. 9.95. Coming in. That was 4.5 or 3.5? 4.5. So we can do a 5.5. Down. Good, 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 good. Whoop. Okay. And that was 4.5 or 5.5? It was something. We'll find it again. 5.5. Doing at a 6.5. You can see it likes being fed. It starts getting chattery when it's not making a cut. All right. So let's double check that we are in the right dimension. Before we keep pushing on. I Just want to make sure everything is sane. This is expecting, we removed 6.55 times 2. 25 mil was the diameter. We should be at like 11.9. And we are at 11.96. I'm happy with that. We are crushing it, chat. You flooding your garage? No, this is just a mist. This mist just kind of evaporates away. I should open a window because it starts to get a little grungy. It starts to get a little gross to breathe in here. It's a little misty, a little foggy. So, we'll open a door. Just get some airflow. Gotta remember that door's open, chat, so I don't get murdered. Okay, do we want to start slowing down? These cuts have been going great, so we don't necessarily need to change anything yet. But yeah, we'll decrease the coolant flow a little bit here, because I don't need as much, I don't think. My view is if the garage is getting misty, I'm probably doing a little bit too much coolant flow. And then we'll go to 9.95. Here we go. 8.58 is the max. And we're just gonna go in, chat. We're going in. We're going in. Are we ready? So we went to 6.5. Let's go 7.5. Down. Okay, definitely a little bit of chatter during the actual cut there. So we'll start changing up our tactics now. Okay, 9.95. Now, let's go to 8. So we're having the depth of cut here. Okay, it's okay. Down we go. That's a beautiful chip. Not seeing any chatter. Chip's a little hot. I mean, it's not. That's actually pretty good. Look at this chip. Look at her chip. Look at that! Isn't that a nice little chip? I don't know how well that shows up on camera. That's quite a nice looking chip. Beautiful, consistent, one long noodle. Okay, I really liked how that went. Let's go and just double check our size. This should now be at 25 minus just 16, good enough. This should be at 9 mil. And yeah, we're at 902. 9 mil. Yeah, we're good. We're good, chat. We're just going to go to our 8. We're going to go 8.5. And then we'll do a 0.08 pass, and that will be our final pass. And then, yeah, we're just going to trust our DROs here, because this has been acting pretty consistent. So we'll go to 9.95. All right, here we go. Here we go, chat. So we're going 8.5. Oh, no. Gross. We got 8.488. Good enough. Okay, good chips. A little hot. Good, 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 good. Okay. Next, we're going to 8.58, which is our final pass, which means we're now going to go to 10 millimeters, right? The 10 is actually our final Z height. So we're going to be removing a little bit of material as we approach, just not too much. And then we'll go down once we get to 8.58. So let's see. Yeah, we're removing just a little bit of material here. I'm going to be trying to be consistent on the speed because this is technically part of our cut here. And 8.58 is the number to beat. 8.58, we're at 8.22, 8.3, 8.5. We got 8.577 is what we ended up on, chat. 8.577. Okay, and we actually did our 10 mil, so that should be 10 mil long, and what did I say? 8.577 times 2, 25 minus that, we should be at 7.84, 7.846, and we are at, let's make sure we're zeroing, we are I think we're good. It's kind of hard to get a good measurement in here. I'm getting like a 7.81. 7.81, 7.82. Okay, let's see if we're off in other directions. Yeah, definitely, yeah, 7.82. Okay, so, yeah, 7.82. I'm happy with that. We wanted 7.84. Technically, we wanted less than 7.84, so I'm happy. Yeah, that's really good. Now, hopefully that's still square. We got a little bit of a burr on the end. That's okay. We can touch that up when we... Actually, we're going to come in here and chamfer it right now. So we're now going to chamfer both parts here. We're going to... I'm just going to put on a... This is just a square. And this will allow us to put a little chamfer on those corners. Just soften them up, get rid of any burrs. Okay. Okay. All right. These ones... Okay. So we are going to have to recalibrate for the new tool. Okay, and then this one I'm kind of going to just have to eyeball. Because there's enough of a burr on here that I can't see the corner yet. Okay, let's see where we're at. I probably don't need coolant here. Okay, we've barely touched it with a chamfer. Let's just say this, re-zero X, because we lost X when we changed tools, so we don't really care. And let's just go to a 0.5 here. .5. So that should be our chamfer on there. Is that true? I want more chamfer. We'll go to we'll do a 1. Okay. Because this chamfer is determining how well we hop on to that die. And then the final thing I'll do is we'll just go up and we'll chamfer. We'll put that same 1 mil chamfer on the outside of the part. Same thing, I'm just going to touch off here to find our 0. Hello. There it is. Same thing here, we're taking a 1 mil chamfer. Looks good. Got a little warm there. You can see the chip was starting to get a little hot. Okay, that looks good. Yeah, the other one is probably not an exact 1, but it's looking pretty good. All right. So, unfortunately, the visibility is not fantastic on the mill lathe, but it's looking pretty good. So, yeah, let's see. Are you able to see the part, chat? How's that part looking? Ah? Can you see the chamfer yet? So that's gonna be the screw, and I think we're just gonna send it for the threading. Okay. Sorry, I don't know how loud that is. Compressed air is loud as shit. My compressor doesn't have to run as much because I have a big compressor upgrade. Blow these off too. Oh yeah. Definitely a big upgrade on my compressed air. That has been a pretty big change. Okay. All right. Now we need to get our die set up. Yeah, I'm really happy with that. Especially with that stick out, but I mean, that's probably not too bad here. But that screw's looking good. We got the 1 mil on there. And then we're really just gonna go for a die. So let me see what size this die is. I think I grabbed it. I pulled it out, didn't I? Yep, M8125. And I don't really know how this works. Because it does have the set screw, which I think allows you to like spread it out a bit or something. Really, I just need to make sure that this goes in square. And the way I'll do that is, let's see what size this is. I need to know what size the outside diameter of the die is, and then we'll figure out how we want to mount it. It's 25.4. Okay. Shit. How am I gonna hold that? Because this has my 25.4 collet. 25.4. Shit. I can't hold the part and this. Right? Uh-oh. 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 Oh, no, chat. What have we done? What have we done? What have we done, chat? How are we gonna hold on to this? Where are my 5C collets? What size are my 5C collets? 26. Yep, these ones, do I have inch 5Cs? I think I do. I think these are inch 5Cs, but they're flipped upside down. Oh no. Oh no. I don't want these to all fall over the rack, but they're going to. Rip. 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 But I think I do have 5Cs in inch. So yeah, these are all inch 5C collets, which I think we'll have a 1-inch one. But I gotta resort them, chat. This is your fault, chat. No, it wasn't your fault, chat. I don't mean that. I don't mean that. Okay. I rarely use my 5Cs. But I think for this we have to. Yeah. Because I could try to thread the die natty, but last time I did that, it didn't go well. So we're going to assume that the reason it didn't go well was Oh, nice. These go real big. Okay. Oh my god. Let's get them back in the thing. Gotta sort them. Okay. Okay. What's the smallest one? 1/8? 1/8. 3/16. Then we want 4/16, which is a quarter. Then we want 5/16. Then we want 6/16. 7/16. 8/16. 9/16. 10/16. 11? Hello? Hello? 11/16. 12/16. Nope. There we go. 12. 13. 14. 15. 16. 17. 18. Nice. Okay. Yeah, we crushed that, chat. I don't think I've ever sorted those that fast. Okay, so I've got a couple tool holders that can handle 5Cs. What's going to be the easiest one to mount? I need to remember to order another 1-inch collet. An ER40 collet, because that is by far the most common thing I hold. I really don't like using 5Cs. They're not very fun. Okay. There we go. There we go. Because I'm going to have to mount this up. I don't have an easy way to mount this up. Let's first make sure this is happy and clean. Looks, it's a little dirty. The 5C collet holder, I just don't like 5Cs. Make sure that's in and indexes. There we go. Because now I have to thread this in the back. There's like this tiny nut, and it's really annoying to thread these. Because I can only do like a quarter rotation at a time. Oh, and it's clogged, so it doesn't want to spin. Come on. Come on. There we go. Some grease in here. A lot of grease in here. Yeah, I would say this is like 1/8 of a rotation per turn. It's really annoying. And I don't know where I'm going to mount this. I think it's too big for the vise. And I don't want to dismount the vise, so we might just put it somewhere on the table randomly. But we'll see. Okay. This needs to aim up. Okay. I'm hoping it will kind of true itself up in here. Okay. It kind of tightened up. The question is that gonna thread straight? And I think it should. So yeah, I guess we'll just clamp that down to the table. We'll do it on your side, chat, so you can see it. And we'll just put it over here on the table. It's not the most precise thing we're doing here, So it doesn't matter too much. We just need this pointed up. I just want to make sure that we're threading square. So this should engage nice and square there. And then we'll just get some mounting hardware for our T-slots. What do we need? How tall is this? Can we directly do it, or are we going to need washers? We're going to need a spacer of some sort. Okay. I took these off the wall. They were previously on the wall. Oh man. Where are my T-nuts? Oh, they're there. Okay. There's a T-nut. This one's stripped. Sometimes the T-nut at the bottom of the pile is stripped. And then we'll just grab some clamps if we have any. Boop. So holding it rigid kind of has its own concerns, right? When you're rigidly holding something like this, you are not giving it compliance if it wants to find its center. So that is one of the spoopy aspects about what we're about to do. I'm just hoping this is going to be better than not doing this. You know, I might clamp this off because how am I going to get a nut on there? So that's going to clamp up. Is that going to run into that? I'm panicking. Okay. It's like you never quite have the right mounting hardware. We'll just go offset. Yeah, like that. There we go. That solves all our problems. Set up our little ramps, little clamps, clamp ramps. One's a little higher. There we go. Should be happy with that. I grabbed nuts, right? Yeah, there. Bam. We're so good, chat. Next is these. Same thing. Looks like we want to go a little above here. That looks good. We can pull this back a bit. We've done it. We have clamped it. Okay. 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 I need a wrench. I forget what these nuts are. These are, I think they're 15/16. Come on. 22/15, which is 8/775. Rich. Is that 7/8? 7/8. We're so good, chat. Okay. Am I going to be able to reach this? I don't know. I'm gonna move this as close to center as I can. With the rotary table on here, I'm just kind of not in the best position for space here. I think I could run out of table travel. So we're gonna get it as close as we possibly can to the side, and I'm just gonna use different T-slots here. There we go. There we go. It's a little closer. It ain't perfect. It's fine. This side will mount natty. The other side will mount with one of these. Come on. Okay. Oh, yeah. Oh, yeah, chat, we're cooking. We're cooking. We have a working strategy. Maybe. That'll do. That'll do. That'll clamp. Give it the clamps. Good. Good. Good, 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 good. Good, 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 good. Okay. Now we gotta get this one in here. Get in there. Get in the T-slot. Get in there. There we go. Okay. Okay. Nice. Nice. Do I have room for this? Yes, I do! Woo! But the taste of blood remains. We're fucking doing it, chat. We're doing it. Hello? Why is that not getting tight? Hello? 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 There we go. Really doesn't have to be that tight. Die, darling, it's cold outside. Woo! Okay. What have I missed in chat? Hi, Roboto. So let's see if we can remove this. Because we need to find center. And we only have to find center once. Conversations with the gun. Is it April 1st again? It is not. This is a real stream, okay? It's not a recording. Happiness and torture me while I... Okay. I forget which way loosens. That way. Okay. Let's find center of this. Got that clamped. Let's go find center. Bought some bitch at the club. How's our part looking? Huh? Is that gonna be a nice screw, chat? Oh yeah. Oh yeah. That's gonna be a nice screw. Okay. Let's get our 3D taster out. We're gonna taste some 3D. And then we're gonna do this on coordinate system 3. Oh boy. Table gets tight towards the edges. Please. Oh yeah, we're good. We're good. Innocent touch. I'll try and get you to be able to see this, but it'll be tough. Okay, we're going to 0. At 0. We'll go to 0 on the other side. Okay. Half x. Okay, now we'll go to the center. So now we know x center, and we'll do y center here. This one's going to be tough because there is that collet split, but I'm hoping if it doesn't have a burr, we'll get a good reading. Otherwise, we can do this slightly offset. I don't like that. I don't like that. Let's just go a little bit offset. Let's just go like 0.6 of a mil. Let's go 1 mil off center. It shouldn't introduce too much issue. Let's go a little more, 1.5 off center. There you go, chat. I just don't want to get a bad reading based on that collet crack. Okay, that's our y0. And then we'll half this. Half y. Okay, so now we have found center of that in coordinate system 3. Okay, we've tasted 3D. And really all we're doing is we're just threading now. So we'll set this to 0, 0, which will be center. And then we're gonna hope to God this works. So that's 0 and 0 and 0. So this should be zeroed. Yeah, it looks center. Okay, that's now set up. The way tech is going, I'm beginning to understand why you picked this up. Yeah, see? It's way more fun. Okay, we've tasted the 3D. Let's put our... Where do we put our die, chat? Did we set our die somewhere and then we don't know where it is? Found it. Okay. Okay. So let's make sure. Yeah. Okay. Oh, now that's tightened in there. Guess I gotta. Whoop! Didn't want to drop it in there. Okay. There we go. Hopefully that's gonna be fine. Okay. So in theory we just thread this. So I'll move the table up here. I imagine we want cutting oil. This seems like a cutting oil problem, right? Where's my cutting oil? Wow. Mobile 1, Vactra. Oh, there it is. Okay. So just. Uh-oh. 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 Gotta fill this up. Uh-oh. I hate transferring oil. This always makes a mess. Some deposits in here. Wonder if that's sulfur, maybe? Cool tool. Cool tool 2. What is this? That's antifreeze. That's my snack. Kerosene. Coolant. Is this it? Cool tool 2. Cool tool 2. Skip. It's a little chunky. Ah! Hope I didn't overfill that. I think I probably did. Let's just go transfer a little back. Definitely a little chunky or moldy or something. I don't know, something's coming out of suspension there. Okay. Cool tool 2. Next. Now we're ready, chat. Damn, I think that's the first time I've had to refill this. Okay. Okay. Oh God, chat. I'm scared. What have you been up to lately? Not much. Just chilling. Been doing a lot of garage projects. Okay, I'll hang that there. All right, we're on center. We could raise the table up a bit more so we don't have as much spindle. Oh God, chat, I'm scared. Here we go. I'm just gonna zero this so it can kind of talk to me. Like, I don't know how much downforce I need here. I think we're cutting. Chat. So, I just don't know how much downforce I need. I think we're good. I think I don't need downforce. Okay. I'm scared. We've got a little bit of feed on there. Come on. Come on. It's gonna go real slow if you don't get in there. Okay. Let's see. I'm gonna give it a little downforce. Problem is with this torque wrench, I don't have much feedback because this is such a big lever arm. So I'm really just trying to make sure that we have some downforce on here so that we don't rip out the first threads, but it probably will start threading on its own here. I'm really just watching the readout. Here, I'll get you in there. I'm basically watching the spindle DRO to make sure that we're advancing, which is here. I don't know if you can read that, 1.57. So what I'm looking for is that we're advancing as we thread more, right? So we have like 2 millimeters roughly of engagement, and I really am just trying to make sure that the spindle just has enough downforce that we're actually threading, but I think we're good. So I don't know if I can do this by hand. It's a little tight. But yeah, now I probably don't need to do the spindle. I think it will pull the spindle down itself. Yeah. Yeah, the threads just need to be strong enough to be able to pull the spindle itself. And those first threads aren't going to be very well formed, right? And we're not going to be able to thread all the way up to the shoulder here. So I hope that isn't going to matter. But I think I designed with enough recess on the other part that this will clamp. And then I have no idea how close we are here. So I'll probably back this out in a bit. Okay. Because we have a little bit of a burr there that's gonna not allow us to go all the way flush. We want to go basically all the way flush. But I think this is going fine. Definitely not the fastest way. Okay. Let's see if we can back it off. We can. That got nice. Let's blow it out. Okay. Hopefully we have no chips. I don't see any chips in there. So we should be able to just go all the way flush now, because I'm not seeing any chips that are going to block us. And I have no idea if I'm going to get feedback when I hit it. I don't think I will, so I'm just kind of going by eyeball here. We're like very, very close. I no longer see a gap. I'm stopping there. There is feedback. It definitely has bottomed out. Okay. 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 So in theory, we have made a thread. And hopefully it's straight and not curvy like the last time I did this. That looks good, chat. That looks good. Okay, let's get you in there. Nice! We did it. That wasn't scary at all. I think dies are just more forgiving. I think alignment matters. I think doing this rigid setup is probably a little overkill, but it kind of guarantees that we'll actually get in there. How's it look, chat? Is that a thread? Does that look like M8125? Hopefully we did the right size thread. So I might come in here and do an undercut because we can't thread all the way up. So I might make an undercut just to make sure that we don't bottom out on the threads at the end there. but we can do that once we actually make the screw. So I'm not going to do that unless we need to. These are stainless, so they're already going to be slightly weaker. We could also potentially put a chamfer on that. It can be scary to chamfer a thread after you've threaded because you might roll that thread and you actually end up kind of making the thread start worse instead of better. But let's see if it threads onto our reference here, and it does. There we go. That's good. And yeah, we just can't make it all the way to the bottom there, as expected, right? So let's try it on our part. Yeah, I cannot control the speed of the moving work. So threads are not forgiving. Okay, we're trying our actual part. Okay, a little tight, a little tight, a little tight. Do we got a burr in here? Did we end up putting a burr? Is there anything in here that needs cleaning? We could also come in here with a thread file. Okay. It's threading on there. It's a little bit of resistance here. I don't really want to force it through. I don't know if that is which part that is, so I'm just going to grab another one. It's possible that there's just a small burr in there, which we could get cleaned out with the ultrasonic cleaner. This one's kind of doing the same thing. So that would make me think it is the thread. Let's just blow it off a bit more. Okay. Yeah, definitely a little tight. I don't know why. Why would that be the case? Why would that be the case? Because the thread checker was fine. It's probably okay. We could probably force it. Yeah, the thread checker's good. I probably went a little too tight on maybe the threading. Maybe I could shave a little bit off. Let's see. Let's force it. Let's force it a little bit and see what happens, chat. Okay. Okay. Definitely a little tight. I think it should be fine. I'll be able to at least chase that and clean that up off the mill. So we'll be happy with that. Okay, so next we just have to cut off our screw. Let's make sure it's the right height, because I think it is. Just make sure it's the right height, chat. Yep, it's definitely 10, which is what we wanted. I think we're good. So we just got to cut this off now. So we want to take 5 millimeters off. Got to scribe this and then cut it. Yeah, we're going to try and cut at 6. Come on. Okay, let's just mark it. There. Let that dry. We'll move the camera over because we'll do this on the bandsaw. I don't want to part on the mill. It's gonna suck. Yeah, my parting blade for my lathe is like it just like doesn't fit right. I don't know if they like gave me the wrong inserts, but it just not a great experience. Okay, we're marking off 6 mil, and then we'll cut on that side. Let's see if I can keep it in the holder, because ideally I don't have to dismount this, but that's probably not going to be the case. I could maybe put this in a V-block. Let's see. Yeah, that's just going to work at an angle. Let me see if I can V-block it. Okay. Where are my V-blocks? There they are. I just don't want to remount this since we already kind of have some references built up on this part. So let's see. So a little cantilever here. It's a little sketch, chat. Bop, 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 bop. Okay. I think this is fine. To cut that off. I think we're good. I think that's going to be clamped in there enough for these cutting forces, but we'll see. We'll keep a close eye on it, chat. Actually, we don't need... We can move the support in a bit more, and that will help us get a better cut on the saw here. Okay. Just moving the support in a little closer here. Keeps it a little bit more on track. Because we didn't give us a huge amount of tolerance here. Okay. Come on. Okay. I nailed the position. Don't want more force. Okay. I think this will be okay. I think. We'll see. Hopefully that doesn't jump on us or do something weird. Long time no see. How have you been doing? I've been doing pretty good. Okay. 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 Yeah, that's gonna be fine. That's gonna be fine, chat. Fucking easy. I don't know why y'all were all so scared. So then I guess we can just start getting the mill set back up, and we just have to repeat that process 4 times. And hopefully it will be a little easier now that we kind of know what worked, what didn't work. I mean, we have everything set up now, so it's really just running ops, 1 train ops. So let's go to coordinate system 1. Actually, coordinate system 2, I actually had all this stuff locked in. So I think coordinate system 2, I can just go back to home. And then that will be home for the other. Bam, and bam, and bam. Okay. Chord system 1. All right. Chord 2, chord 1. Let's get our tool set up. How's the cut going, Chad? Are we good? Is our cut going well? You guys are the ones watching it. So if that explodes, it's not my fault. You're the ones watching it. I'm over at the mill. Okay? Okay. Good. Lock down our tool. All right. Oh my God, chat, this is going so slow. Yeah, this blade's probably a little too fine for this 1-inch cut. Whatever. It's fine, it's good enough. Okay, well, we're set up on the mill. What about our RPM? Yep. Yeah, we're ready. We're ready, chat. We're just waiting for the piece. So, I don't know what you guys are doing over here, slacking. Taking your time, chat? What's this? What's going on? Huh? That's going to be hot when it comes out. Ba, ba, ba. Ba, ba, ba. Come on. You guys are taking your time. Jeez. Why is this going so slow? It might just be the wrong tooth size. Or this blade might be completely dull. But it probably shouldn't be this slow. There we go. Okay. There we go. There's our screw. You guys did that. You made this. You made that. Look at that. So proud of you guys. Let's see how thick our head is. Head is 6.1. Okay, so we nailed it. So that head We want to make it 5. We did 6.1. Our kerf is probably 1.5. So we should be on track where we can just keep doing parts. Okay? This is a parts factory, chat. All we do is make parts. On to the next $100 screw. Okay. Definitely got hot. That blade is dull or configured incorrectly for number of teeth. Okay? But that's okay. It's all right. We'll send it. I've got extra blades somewhere, but I don't want to change a blade. That was good enough. Goodenough.jpeg.co.uk. All right, so now we have less stick out, which makes sense because we've removed parts. So, same operations. Looks good. Looks good. Okay. Okay, and we'll just touch off, and we'll just call that 0. There we go. Okay. Touched off. Let's get our calculator back. That had our cut depth, which is 8.58, chat. 8.58. 8.58. And then let's do the same thing. We'll face it off. We'll set we'll get a flat face here, because right now we just have that saw finish there. So it's got a flat face, just so we get a reference, make sure we actually have the right amount of material on here. What's being so noisy? A little better. I don't entirely know what's going on there. Okay, anyways, we gotta re-zero this. Bink, bink. Slide that off. Zero that. Let's take off 0.1. See what we get. Okay, that's cleaning up. Wow, that was a straight cut. Good. Okay, I think that's all we need. I think we actually just cleaned that up in one pass. Yep, feels good. Okay, so now we're doing the same thing. So Z is set up. X should be good. Let's double check. Let's make sure we didn't bozo it, as Ox Tools would say. And yep, good. And we're going to 9.95. And we're making our cuts, okay? Okay, chat. Someone start a timer. And this time we're doing 1 mil at a time. Here we go. Little hot. I think the cutter's a little dull. It's all right. For these rough cuts, we'll be fine. 4, 9.95. Here we go. Go to 2. Down. 9.95. Good. Okay. Nice. Okay. That was 4. We go to 5. Beauty. $9.95. So that was 5. We're going to 6. Definitely running hot. Fine, we'll keep doing it. Like, good enough. Okay, we're going to, that one was 5. Going to 6. Wait, that was 6. Going to 7. Okay. Next pass, we're going to do a 0.5, and we'll do 0.5 from this point out. Was that a 6? I think it was. So we're going 6.5. Wait, was that 7 or 6? I think that was 7. 7.5. There we go. That's a nice cool chip now. Okay. Way better. Good, 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 good. Okay, let's set that as our 0. And now we're going to measure how much we want to actually remove here. When did you get the mill? I've had the mill for like 3 years. Target is 7.84. She hot? Nope, not really. 7.84 is the target. We're probably at the 10s right now. $9,961, $9,960, $9,960, $9,960. So 9.960. We want 7.84. That gives us 212 divided by 2. That's a 1.06. Okay. Oops. Okay, let's go to 9.95. Okay. So 1.06 from here. Right, 1.06 from here, so we're going to go 0.5. Yeah! There we go. Okay, then we're going to go to 1. Good. Okay, this is our final. So let's go to 10. So 10, we're going to touch a little bit, and then we're going to go to 1.06. One. Should be it. Boop! Okay. Let's see what we got, chat. Place your bets. Place your bets. Place your bets. Looks like a 7804. 7804. Happy with that? Okay. Now, I think I'm going to go and cut that relief in here that I kind of wanted to do before. And I think we're going to do a 1 mil relief here. And we'll just do like 2 mil of it. So I guess we'll do 2 passes. So let's go up to right at 10. And we'll do a half mil per pass. Because 1.06, so we'll go to 1.5. And then we'll feed down to like 8.5. Okay, same thing. So we're gonna go back up to 10. Okay, 10. Now we're gonna go to like 2. There's 2. And then we'll go down to 8.5. Is that what I said? Okay. Okay. That was more than I wanted to. I guess that was 2 mil because I was removing radius. A little more than I wanted, chat. But it's fine. It's fine, chat. It's fine! Fuck! That was a 1 mil undercut to 8.5. Just so we remember that. Because we need to do that on the other parts. Okay. It's not scrapped. It's just bad. Alright? Well, now we know where the screws will fail, if they fail. Which they won't. These screws are perfect, okay? Alright, we'll do the same chamfers, which we did a 1 mil chamfer on both. Quite a day at the screw factory. It's a disaster. It's a disaster, chat. Okay, let's see if we can find where the edge is. It's
still burr. I think this is roughly 0. We'll see. There we go. I was right. Fuck yeah. Okay. There we go. I don't like how much I necked this screw down, but I do like how this screw looks, to be honest. I think this one looks a lot prettier than the other because it has that kind of cool feature. Same thing here. 1 mil chamfer. Okay. And then hopefully this will survive threading because we did neck that down a bit. But I don't know if you can see that on camera. Can you? Okay. Well, now we're going to go to coordinate system 3. And it's time to thread. See, was that bad, chat? We made such a big deal out of that. I knew that was gonna go great. Okay. Smells like oil. Smells real good. Okay, we're at 0, 0. I'm gonna pump the ways again. Do I actually have oil in there? I do. We're good. Okay. Same thing. Let's put our cutting oil on here. Shoot-a-doop. Lubed up. Okay. Hopefully this can survive the threading forces because we did neck it down a bit. Everyone being good though? Okay. Here it is. Okay, she's talking to me. She's talking to me. Should be decently started. Let's start cranking on it. Oh yeah. Oh yeah. Oh yeah, chat. Okay, we probably have 1 thread fully engaged now. Okay. Ankle biters. All right. I think we should be good. It should feed itself. It does. Okay, let's back it off and then clean it out. Make sure we don't Crash! Okay. Okay, I think we're at the bottom. Yeah, I'm gonna stop there. Okay. Probably can hand feed it out. New air compressor is pretty quiet. The grand scheme of air compressors. Beautiful. Beautiful. She's ready for the cut. How are you liking this one, chat? Look at that. You like the undercut feature? Ah? Ah? Then we don't have to worry about it not being able to thread all the way up flush. Let me, let's give you a comparison. So I think we're gonna do the same thing to the other ones. But yeah, look at that. Look at that. With that undercut. Beautiful. And here it is without that undercut. Right? Is the one we already made. So I'll have to come back in and add the undercut to this, which sucks. That's kind of one other op, but it shouldn't be too bad. Okay, so we'll do the same thing. We'll mark this part. Man, that actually looks so clean. That actually looks so clean, chat. Like, come on. Come on. Look at that. Look at that. That's a nice looking screw. Fuck yeah. I'm actually so happy with that. Okay, same thing. Marking at 6 mil gives us 1 mil to take off. Changing me into Dusty. Boop. What a good screw, chat. Definitely a little overkill, but it looks good. We are making an heirloom piece. Okay, we've got a part marked. Let's see where we end up today. Bah. Okay. Okay, it's starting to get a little sketchy on that work holding, but I think we're good. Okay, this should be good. Let's see. It's less stick out. Okay, we're good on our positioning. All right, we're just waiting on that. Next is, let's just get the mill prepped again. Or we could actually finish up that other part, can't we? Well, I don't have a way of holding it, unfortunately, because I'm using that tool holder. So we'll just, yeah, we'll just set up the mill for the next part then. Same thing, coordinate system 2. But yeah, this is going pretty good. Okay. Boop. Bam. Bam. Okay. We've zeroed out coordinate system 2. And we'll do coordinate system 1. Good. Coordinate 1. All right. How's the cut going, chat? Answer is very slowly. Very slowly. Yeah, I need to figure out how I want to do that last undercut op. Oh yeah. Having better compressed air is nice though. I effectively have unlimited air now. I can run that air gun at like 100% duty cycle and I don't run out of air, which is pretty nice. Definitely a big upgrade from my previous setup where I'd run out of air after like a minute. Okay. Okay. Got the tools set up. Good. How are we doing over here on the cut? Oh. Okay. Yeah, now we're just waiting. We're just waiting. How's chat doing? Talk with chat. We'll do the same thing here. Thread on a part so we can grab it when it falls. We got some nice parts, chat. Danger! Danger! How's she doing, chat? She speeding up? Come on. Nice. Okay. So there we go. How's that looking, chat? That looks good. That's a good looking screw. Okay. Next. Let's make sure we're good on head height. 6.21. So we went a little tall on that. It's fine. Okay. Okay, next screw. That one was probably like a $50 screw. This one's gonna be cheap. Okay. What have we learned, chat? Okay. Oop, boop. Okay. Same thing. We'll just go up 0.1, roughly-ish. I think that's all of it. I think we touched it. That looks good. Okay, so that's now our 0. Let's move Z up a little bit. Let's touch off, find an approximate X. Should be good. Okay. All right, here we go. Up to 9.95. And we're doing the thing, right? Any regrets, chat? Are we doing anything wrong? Anything gonna explode? We're doing 1 mil cuts. Why is that being a bitch? Is our insert fucked? Is our insert fucked? Think we're good? Okay, down. We'll see, this insert might have to get changed out. $9.95. Now we're going to 2. Yeah! $9.95. This one's going to 3. Okay. 9.95. Are we going to 4? Good. .95. Okay. 9.95. What was that, 5 or 4? That was 5, so we're going to 6. Yikes. Don't like that. .95. 7. Yeah, I think this insert's pretty burned up. Okay, so let's see. Is this hot? Yeah, part's starting to pick up a little bit of heat. So we'll let the part cool off a little bit here. But I think we're good. I'm not gonna change out this insert because it shouldn't matter too much. But we'll 0 and we'll set our 0. 10.940. 10.945. 10.940. 10.940. 10.940. 8.58, or wait, what's the target? 10.94. The target is 7.84. I say 10.94. What did I say? Yeah, 10.94 minus 7.84. So we need to go 1.55. We're going to do this in half mil passes now. Okay. 9.95. Here we go. Oh, yeah. Fine. It's fine, Chad. It's fine. It's fine. 9.95. Now we're going to 1. And then we're going to do a point. Yeah. Going to 1. Cutting. 1. Down. Good, 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 good. Good chip. Good chip, chat. We're crushing it. 9.95. Now we're coming into 1.55. This will be final. One. 1.53. 1.538. This should be fine. This should be fine. Cope, 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 cope. $7.858. 7.857. 7.857. We want 7.84. Let's take a little bit more off. Since it is a thread, we're already having some meshing issues. $9.95. And we'll go a 156. One. One, 5, 6, 7. Very light pass. $7.75. Good. 7.75. Now, we were doing a 1 mil undercut to 8.5. So we'll go up to 10. So this one is true 10. 10.0. And then we're going down to 8.5. Okay, so we'll have a little bit of cutting. I can't remember if I zeroed X, chat. I think I did. Yeah, I did. At 0.5, then we're going down until we hit 8.5. 8.5. Okay, same thing. Back up to 10. 10, and then we're going 1. Cutting. Going down. That is 8.5 and away. Okay. Now we're just doing chamfers. That insert's not very happy, chat. Okay, just chamfers. Bum, 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 bum. Okay, chamfers. Yeah! Yeah! There we go. That was tight. Okay. That chamfer going yet? Or is the burr gone yet? Oh, there's still a burr. There we go. 0 that, 1 mil from here. Okay. Same thing. Lock. Touch. 10.35. 10.35. 33. 1 mil chamfer. 1 mil. There it is. Woo! Okay. It's thread time. Chord system 3. Off we go to the mystical place of chord system 3. What chord system do you guys like, chat? Is that fun? Is that engaging? Chord system preferences? I don't think live machining is really a figured out thing yet. On a porch. Okay. Bam. 0, 0. And then we'll go up a bit. We'll go into Nooch. And here we go. Are we good? Are we ready? We can thread, right, chat? Right? We're ready? We're going. Get in there. Get in there. Get in there. Whew. Okay. Here we go. Here we go. This is going to be a big turn. Ooh, yeah. Oh, yeah. Okay, we're probably good to free. Yeah. 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 Who's cutting threads now, chat? Huh? We are. We're cutting threads. I feel like we're kind of crushing it. 5. I'll go up a bit. Get that cleaned out. And we'll keep going. Oops. Boom. Boom. We're flying. We haven't even broken apart yet, chat. I think she's tight. I don't think we push it. I don't think we have to, because we added that relief. Get out of there! Get out of there! Bam! Bam! Okay. Oh. Yet another perfect thread. Hello? You in gear? Yep. Okay. Ah? How's it look, chat? Rate the thread. Rate the thread. Rate it. That's looking good. That's looking good. Good morning, Emil. How's it going? Okay. Okay. 6 mil. 6 mil. Roughly here. I feel like we've been crushing these. Drying off the Sharpie so I can mark it better. Okay. That's ready to cut. Man, that turned out good. Is that the best one? I feel like the first one turned out the worst. Oh, the second one's really good too. I think the first one kind of got fucked on the chamfer. I think I didn't go for the full chamfer depth on accident. But that's okay. We'll just we'll be able to touch that up on the we'll touch up the chamfer on number 1. Number 2's good. Number 3 is just art. Yeah, number 3 slaps, chat. That one turned out really good. Okay, let's cut this off. I might have to do a completely new setup for this, because I don't think I'm going to be able to grip this the way I was gripping it. Oh, wait. Okay, I got an idea. What are you cutting threads for? These are for my insert holders on my fly cutter that I showed off at the start of the stream. I'll show it off in a bit. I gotta vacuum up some of these chips. Okay. Let's get this cut going. I don't quite know how I want to hold it this time. Ugh. I could disconnect it. I just don't want to. I like this being where I know it's good. Man. The vise on this is like never where I want it to be. It's really frustrating. Okay. Let's see. Let's see if holding it in a vise helps here. It's kind of random if this helps or not. Okay. Because what would I want? That's awkward. Any thinking colons? Carry the 1. See what happens if I clamp it down. Damn. Vertical? Vertical. That'll do it. We're going vertical, chat. I guess we got to cut from the other side. There we go. This is it, chat. This is the setup. There we go. This is gonna have to move back so we don't crash. Come on. That'll juke. I think we're good there. Yeah. 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 This is it. This is it, chat. This is it. This is the one. I don't know why there are so many doubters who didn't think that this is going to be the way to clamp it. Turns out, I was right. I think that's it. I think we're ready. Is everything tight? Okay, here we go. Nailed it. Nailed it. Okay, so yeah, the whole point of this project is we're making little threaded holders for this, which is a fly cutter. So this big boy is my fly cutter, and I have these little insert holders that will hold a carbide insert. So the insert will go here at the circular part, and then this needs to be locked into the disc. So I want to be able to throw this into the disc, and then I need a way of holding that in place. So if I go from the other side, you'll see that this is recessed a little bit. And the point of that recess is that if I get a screw that clamps on the top, that should hold it rigidly in place. So that's what we've been making. We're cutting off our third screw. We've made 3 so far. So here's the first 2. So here's number 1. We don't like number 1 because we can't thread all the way to the shoulder, right? With a die, you can't thread right up to a wall. Really anything you can't thread all the way to the wall. So on the other parts, we actually put a small little recessed area there. And so now that will thread all the way flush, right? That neck is thin enough to go all the way into that blind part. So we're gonna have to add that feature to this. We'll just have to mount it up and set up that same feature on this one. But that's fine. And then so far, basically these are complete except for the top side. So we obviously need to come back in, do that feature, and then we just have to face these off, and then just chamfer them, and then add a slot to them, which is something I could start looking at now. So that cut's about halfway complete. So let's see. I'm just gonna use the biggest screwdriver I have, right? Might as well. And then we'll just figure out how big this tip is. So I think this is my biggest screwdriver. 1.2 by 8, which I think means it's 8 wide, 8 mil wide. 8.2 wide, yep. And then at the very tippy tip, it's 1.1, and then with the depth I want to go, which is probably like, I'll probably go like 3 mil deep. Yeah, we'll go 3 mil deep, which is, we probably need like a 1.5, 1.6. What would I have for an end mill in 1.5? So I need 1.5. I might just go... Do I have a 1.5 mil end mill? 1.4 drill. I've got a 2.0 end mill. So 2 is an option. Yeah, a bunch of drills. I have a 1.5 reamer. Yeah, looks like we might be doing a 2 mil end mill on there. Let me check my other end mill inventories. Okay. Whoa! I just finished? Okay. I think it kicked off a little bit at an angle, but that's okay. At the end there, I think it twisted in the vise, but it's fine. Cutting tools. 3 mil, 2 mil, 2 mil, 1 mil. Man, I swore I had a 1.5. Because I definitely have 2s, I definitely have 1s. Where would the 1.5 be? I think the 1.5 was a special one for, I think that one was for hardened steel. So it's gonna be loose somewhere. Where would that be? Yeah, I think we might just do a 2 mil. Just because we're going to be slotting anyways. Slotting with the 2 mil end mill is going to suck ass, okay? I don't think y'all understand how much it's going to suck ass to do this cut. And it's going to be pretty deep, too. Because we're going past diameter and depth. So yeah, I think we're going to just do our 2 mil end mill. That's going to be our slot. So here's that 2 millimeter end mill. I think this is a Firex one. I think this is meant for hardened steel. So that should be quite nice for this. Okay. Where did our part go? Where's our part, chat? Tip tray. There it is. That is hot. Yeah, that blade is not cutting well. That's fine, whatever. Okay, let me grab this part so I can set it on the table so it can cool down. So that one is very hot. But we're looking good on height there. And then let's make sure we have enough left for our final screw. Because it's possible we run out of material, but I think we're good. I think this is enough. We need 15 mil, and I think we have more than enough here. Oh yeah, we're totally good. We're good. All right, our kerf estimate was pretty good when we decided how long to make this. Okay, up we go. Okay. Make sure everything clears. Then we're going over to chord system 2. And we'll find 0. Zero. The 0 for X doesn't technically matter here. Okay. It's really just Y that we're picking up here, which is our cutter center. Which we eyeballed anyways, so really doesn't matter at all. Okay. Let's see. Yeah, the cutter got hot. We could replace it. I think I have more of these. Inserts. Where's my insert stash? Bottom way. There they are. Woof! I only have one more. Okay, we're gonna have to order more of these, chat. I feel like I'm getting pretty good number of cuts out of these, though, which is good. It's good to be wearing these out instead of chipping them. So these cuts will hopefully go a little cleaner. Yeah, a little burnt up. It's not terrible. It was probably usable, but let's just see. Part of this is like A/B testing, just seeing how different it performs and feels. When we got a nice clean insert in there. But with you I do. Till we run out of road. In the passenger seat. Okay. It's better than this. Man, T-Swift, old T-Swift. Hell yeah. With you at best, just fearless. Whoa. Well, to be honest, we could go lower on this, but I'm not going to because we have a system. It's working. We're not going to fight it, okay? No fight in the system, chat. This way, but it's the first. So this one's probably going to be harder to clean up because I think this saw cut went a little sideways on us. Okay, so let's go. Yeah, we'll take 0.2 off. Okay. I think that cleaned up. Nope, still needs more. Okay. Looks good. Wow, more. That's good. We're good, chat. We're good. That's our 0. Okay, next. Up. Up, touch off. Find our 0 for X. There it is. X is zeroed. Now we go to 995 and we start making cuts. Right? There we go. So 8.58 or is that where we're going? Is 8.58? I think so. Okay. Here it is, chat. The first cuts. Down. Okay, 995. Now we're going to 2. $9.95. Now we're going to 3. Up. Okay, I think that was 3, so this one's going to be 4. Okay, let's find our 0 now. Make sure that part cools down, and then we'll find, we'll just make sure we're cutting. Good spot. $14.863. $14.859. $14.859. $14.859. Target is 7.84. We have 3.50 to go. Okay. Easy. So now we're going to 1. Down. Uh, 9.95. Now we're going to 2. Yikes. Why is that being annoying there? Okay. $9.95. Let's go to... that was 2. Let's go to 2.5 now. Okay, now we're doing halvesies. This is going to be 3. Okay. This is going to be, we're just going to go straight to 3.51, which is final. Okay. Let's see how we did, chat. What was our target? 784. $7,896, $7,895, $7,895, 0.05, $7,894, $7,893. So we're a little big. So we basically want to take off 0.05. Yeah. Yeah. Okay. So now we're going 0.0. We'll do 0.047 because that's what we got. Good. Finally, let's do the recessed area. So we're gonna go all the way to 10 this time instead of 955. And then we're just going in 0.5 down to 8.5. Okay. In theory, we're gonna cut here a bit while we come in. Okay. Then we're coming in. Here we go. Cutting. Okay. Down. Down, 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 down. Down, 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 down. Okay. Good. Good, 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 good. Back up to 10. Okay. We're at 10. We're going to come into 1.0. Okay, we overshot a bit. We went to 1009. Actually, that's fine. That's 9 micron over. $8.5, get out. Okay, now it's chamfer time. Woo! She's looking good, chat. There's your lip vibration. Okay, I'm actually going to face it off because I technically have 0 set. So I can just do another pass at 0 and that should get rid of the burr. And then I'm not guessing as much on making this chamfer, which has been a problem for us. So this should be removing basically nothing except that burr. There we go. Okay. Now this chamfer will be way easier to do. Because I don't have to break that edge. Because I'm pushing a burr down that part as I'm making these cuts. God damn it. Yeah. Okay. Next, chamfer time. There we go. Now I can do the chamfers the way I like to. Doing a 1 mil chamfer. Okay. Up to the next one. Okay. There we go. Okay, chamfered. Now, thread time. Chord 3. Okay. This is it. Definitely tight on the table out here. I'll redo my ways once I make my surface grinder, which is kind of what this project is for here. Okay, let's go up more. Okay, this is it. This is it. Get in there. Get in there. Okay. Okay. We're doing great, chat. It's all thanks to you guys. You guys are doing this. Well, unless this part's scrapped. Then it's not your fault, chat. 2.8. Let's go to 3. There we go. That should be enough thread engagement for it to feed itself. Oh yeah. Oh yeah. Okay, a little bit more. Get in there. Get in there. That's at 6. We can keep going a bit. Then we're going to back it off a bit here, blow it out, finish it off. Nice. I'm dreading the 2 mil end mill. It's a small end mill to do slotting in. A little more. Where's the bottom? That's it. That's the bottom. Whoo! We did it. We did it, chat. We're out. We're out of there. Beauty. Okay, we're done with the die, I think. Beautiful. It's beautiful, chat. How are we so good? How are we so good, chat? EZ.
Okay, let's do one. Now we just have to cut this off. And then that's it, chat. And then that's really it. I guess we're actually going to remove this now. Okay. All right. Next. Remove that. So we're gonna finally take it out of the holder, which then frees up the holder. Might need that wrench again. We'll see. Come on. Yep. There it is. Okay, and then that's the last bit. So that was the raw metal that we had in the chuck, and you can see the finish that we got there on each step up from there, and then our screw. So that's looking really good. I'm liking those. I think it's really just that first one that I don't like. So, and the second one could use a little bit more chamfer, a little more lead-in. But third one looks good, fourth one looks good. So I think we really kind of got that process down on the final ones. Yeah, I really like how that undercut's looking. I mean, it just won't have any risk of bottoming out. These don't have to get too tight. So we do lose some strength there, obviously. So now I'm gonna mark this off. 6 mil like we did the others. So find 6 mil roughly. Put some Sharpie on there. Dry the Sharpie. And then we'll give it a scribe. Okay. And then we'll cut that off. Is that 6? Yeah. Okay, so same thing. Just gonna mount this up somehow. Haven't really decided how yet. And we just gotta cut that off. Okay. Let's see, how's this gonna mount today? I think we're going vertical again, chat. Ah. Hold that in there. How much clearance do I need? None? Okay. 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 We're so good, chat. We are so good. And slide that a little over. I feel like I'm getting a lot better at sawing. I feel like I'm hitting these bandsaw targets within like 0.25 of a mil, which is pretty damn good. How am I going to clamp this in here? Let's see. Let's see if this will clear. Okay. Saw. Engaged. Everything clears.
We are sawing, chat. We are sawing. Okay. So next, we could start trying to clean up the first part because we're gonna have to remount that. Yeah, the first part is the only one that's gonna be kind of tricky because we're gonna have to remount it. Yeah, so I need to deburr it because right now we got the burr on it. That's obviously going to prevent us from clamping it accurately. So I'm just going to grind that quick and we'll deburr that on the grinder. Really, we're only deburring this. We're going to end up removing a mill. We don't want to deburr too much because we could potentially eat into the final dimensions of the screw. But we are going to take a mill off of this. Okay, I think we're good. Yeah, it should be good. A little bit there. Go. Okay, so that's cleaned up. So this should now clamp smoothly. It doesn't have any protruding pieces. So might as well clean up the others. Well, we kind of have this already set up here. And this deburring is literally just so we can clamp the part. Because the surface that we're removing, or the surface that we're deburring, is actually going to go away. Because we're going to change the head thickness on these. Okay. That one feels good. And we'll do the final one. The saw's going well. It's about halfway. Okay. There's a weird kind of chip in here. Must have been a chip when I grabbed this and I kind of marred the part a little bit. Sad. That's good. Okay. So this one looks good. Yeah. So this one's kind of the worst one where it cut kind of at a weird angle. Might have been that we weren't there to support it at the end of the cut. Might be that that blade is at the end of its life. But doesn't really matter. We're gonna clean that up anyways. So let's go. What's the thing I want to do the least? I think the thing I want to do least is go in and fix and add that recessed feature to the first one. So I guess we'll just go and do that now because I really don't want to do it. Okay. Saw is complete. Gonna have to grab that with some tongs because it's gonna be hot. We'll have to deburr this piece as well. And by tongs, I mean calipers. Okay. While that's cooling, we can now finish that one part. So lock the saw. E-stop is on. So it's going to be a little bit difficult to find where we want to touch off for that recessed area, but we're just going to have to YOLO it, okay, chat? So let's go get this mounted up. This one, we're going to have to mount up in the direction to get access to that thread. We're also going to hit that chamfer just to clean it up. And we're going to switch from our 25 to 26 mil. And we're going to switch to our 24 to 25 mil holder because our part that we're grabbing onto now is 25 mil. It's not the 25.4 anymore. So we actually want to be on this new collet. So we'll switch over to this. Come on. There's something in here. Come on. Hello? I'll blow this off. There we go. Something was in there. Okay. Now we're pointing this one out. We can't put it in here deep because we have to go all the way up to that wall. So let's see. Okay. Hello? I guess I shouldn't be going for max torque because I don't have full collet engagement. So, that should be good. So we've got a very, very small raised area, so we should be able to get in there. Finish that undercut, and then chamfer it, and send it off. So we're going to have to make sure we have clearance because we have not done a cut with this setup. Since this is a new setup, it's very plausible that we can't, that something will crash. So we got to make sure everything clears now that we're doing the new one. So center is still the same. We can go to mode 1, record 1. So we'll go to 0 on Y. Whoop. Okay. Now we got to put the diamond insert in. Da-da-da-da. Okay, we go. So we're gonna have to pick up X off of a thread. It's gonna be really hard. Picking up Z is gonna be pretty easy. We're just gonna touch off on that. Pretty happy with that. So we'll call that 0 for Z. I guess we can go to where this touches here, actually. 3, 4, 5. Let's see if it repeats. Yeah, I'm actually really happy with that. I think we're right in the shoulder. Okay. Good, looks good. So we're going 1.5 down because normally we go 10 to 8.5, but we're going 0 now. This might remove a tiny amount of material. Nope, which is good. We don't really want it to. Then we want to go 0.5 deep, then we're going to go down. Here we go, we're cutting. There's our 0.5. Now we're going down 1.5. I literally can't even see what I'm doing right now. 1.5. It's working. Bam. There we go. Now we're going to 1.0. Going down 1.5. Bam. Get out. All right, let's see if I hit it. Yeah, it looks good. Okay, we got a little burr there, that's fine, as expected. And then we just have to finish that chamfer. We're probably gonna have to eyeball this. It's gonna be hard to pick up our correct X for the chamfer. I don't think we have any features we can key off of here. So, just fine, it's not the biggest deal. I mean, I think we can treat it like there's basically no chamfer. Just right here, reset X. Here we go. Okay, so this part is now much better. Nice. So we'll have to thread file that, because when you chamfer after threads, you've damaged the thread, right? We've pushed a burr into those threads, so we'll just have to come touch that up. But yeah, we've added that, that recessed area. And we're just gonna have to clear that up kind of by hand, probably with a file, but that's fine. So now we just have to do the last two dimensions, which is just facing that off and setting that thread height, or setting the head height. So yeah, I think all the tough operations are done. Definitely did a little more chamfer on there than I needed to, but it's okay. It's fine. It's not the end of the world, chat, okay? Not the end of the world. Come on, pop up. Come on. You are, it's not, you've been. There we go. Got enough thread on there. I'm happy with that. This one definitely has the biggest lead-in chamfer. And that final chamfer, I think, is just a rolled over thread. So we'll probably just run the die back over that, and that will just clean up everything. But we have plenty of threads on all of these. Yeah, we just have a bigger lead-in on that one. I'm happy with that. That's good. Okay, so the next thing we need to do is we need to set the head height. So all of these are just rough cuts on one side. One of them kind of is not the best chamfer, but we basically just have to face these off and then figure out how to set the height on them. One way to do that would be to have a way that we can index off the centers here. Let's make sure we don't have any raised centers. I don't think we do. So I could potentially put a little stopper in the collet, and then we just run them all at the exact same depth. Let me see what the inside of my collet looks like here. That's going to be tricky. Okay. Yeah, we just have to figure out work holding to set these heights. Okay. So really what I want to do is probably put something in here that physically prevents them from going further. And then that will allow us to set them all at the same height. What would go well in there? How deep is that? And it doesn't need to be a precise stop. It just needs to be parallel. Doesn't have to be anything too crazy. It's approximately 56 mil deep to that flat face. Double check. 5577. So we need something. What are we thinking, chat? Let's see what random pieces of machined shit I have. Because it needs to fit in a 25. This will. $36. So I have this just off cut, but this has been faced on both sides, so it will be pretty much parallel. And that should slide in here. That sets a stop, and then we should be able to set this on top. And I think that's gonna go in there too far. Yeah. We need to add a couple millimeters here. Okay. We need like 10 millimeters extra. But I think I like that. Oops. Gotta remove this part. Not to you. And then we're probably not going to hit a head height dimension. I think what we'll do is we'll just kind of true them all up and just see what we get. Come on. Dirty in there again? Okay. Oh, what do I have? What do I have that'll add just a little bit of height? Good. I think like just a washer would be fine. They're not going to be tall enough. What do I have, chat? That's not tall enough. A nut? A nut would be good. Am I good? Let's see. I do like this part because this is gonna sit in there nicely. Yeah, like this nut. I could throw this nut in there. That's good enough. We'll throw a nut in the bottom. I've just got a nut. That should add enough height. And it looks like it's sitting flat enough. So then we put that piece in. And then we put this on top. Oh no. Oh wait, it will be enough. Oh, is it too tall now? No, it's too tall. Fuck. Okay. The nut's too big, chat. It's like, at this point, do we just make something quick to do this? I don't think so. I feel like I can find a random piece of scrap that's good enough. I could just cut off a piece of something. I'm just afraid it wouldn't sit flat enough. Maybe we do just want some washers. All right, we'll do washers. Washers. Wash your back. Okay. 2 washers? The problem is, like, I don't know if I'll be able to get this consistently in the same spot. It's fine. It's good enough, chat. It's fine. It's good enough. Good enough, chat. It's fine. Please. Please. Is that bottoming out? No. No! We need one more. Fuck! Do we need one more or 2 more? I think we want 2 more washers. Okay, this time for sure. Four washers. 1, 2, 3, 4. Stack them up. Stack them up. Get them nice and stacked. Get them in the center. Stack them up. Okay. Okay. And we put this in. Okay. Then this goes in. Oh my god. Oh my god. Oh man, that's tight. That might not be enough for all of them. Fuck! This is a disaster, chat. I'm starting to not like this. I don't like how many washers we have in here. Okay, how tall is this? This gives us an idea of how tall we need to be. 6 mil. 6 mil. What would be 6 mil? 6 mil. 6 mil. Could literally have made a part by now. How tall are these bad boys? $458. I don't know. So this is 639, which would be fine, but I don't know if this touches the bottom. Does it? No, I think we're good. I think this will fit. Oh, I'm liking this, chat. I'm liking this. Bam. Bam. Get in there. Oh, yeah. There it is. Okay. Now we need to figure out what the shortest one is. Who's got the shortest head? Uh, 610, maybe a 590 in places. Okay, 590, 620, 617, 612, 621, 629, 613, 614, 624, 626, 644, 640. Okay, this is the shortest one. And where's the shortest spot? Doesn't really matter. We'll put it in. And then this one. How am I going to chamfer that? I guess I don't care. I'm just facing all these. I might be able to chamfer in here. I don't know if I have a mil of clearance. So I'm going to need to remove that. Oh, man. Oh, we might be good. We might have... We have to remove 0.5 mil from this max. Okay. Here we go. Bam! Click! Okay. We're ready. We're ready. Our ghetto stack is going to work. Now, we're just going to do the same cut on all of them. Woo! Robots can't do this. This is not a robotable thing. This is too hard. Robots aren't smart enough. Okay. 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 We have to pick elevation here. We're gonna 0 that. We gotta not fuck up these. we cannot fuck up our zeros, because this is going to affect all parts. Okay, let's call that 0. And then let's find the lowest spot. This is going to be the lowest spot here. Okay, that 0, we're calling that 0. Okay, so let's take off 0.1. And let's see if that cleans it up. So we're going to go up 0.1. 0.1. And we're just going until this cleans up. And then we're going to do the exact same cut on all the parts, I think. I think that cleaned it up. Yeah. So we went a little fast at the end. I rapid it out, which I don't like. So we're going to go up just a bit more. Now we're at 0.15. We'll 0 that. We'll take this cut. This is setting our head height, whatever that's going to end up being. Okay, there's center. Now we're not going to rapid. Good. So, there's our head height set. To remove this, I have to go to 0. It's fine. It's fine. I'm not happy about it, but it's fine. Okay, so now we have a nice, clean face. So that is the face of that part. So what I can do is, now we can change this out for another part. We're going to do the same cut, same depth, same everything. If we want to do 5 mil, we could actually potentially do that adjustment here, where we basically, we can now measure this part once we take it out. Let's see what we hit. We wanted 5 mil. We don't really care. What are we building? We're just building some screws. We got 5.7. So 5.7 mil. So there we go. So now this screw is almost complete. It just needs a chamfer and then a slot for the actual screw head. And this will be done. Okay? So, yeah, I'm happy with that. Okay, next. So we're just going to do all of these operations now because we can't really do any other ordering here. Okay, let's make sure that sits nice and flush. It does. Clamping. Okay. Click, you bitch. There it is. Okay. Same thing. Okay, this has to come down. There it is. Okay, now let's go down a bit, because this one might take a different amount of cut. So let's just go down 0.1. So we're gonna leave 0.1 on, then we'll come back and do a 0.1 pass. Okay, and then we go to 0. And this is final. Beautiful. Okay. That's all we got to do. And in theory, this is probably going to be within probably 0.05, hopefully, of the other head height. Who knows? But there we go. This one's done now. And hopefully, it has the same head height, roughly. This stack up in here probably moved around a little bit, so it's hard to say if it will be perfect, but, you know, it's good enough, chat. Let's see what we got. So the first one is 5.7. This one is 5.61. Yikes. 5.7 in one spot. 5.6 in another. Is that a burr? 5.7. 5.6. Oh. Okay, so they're both... I think they're just not seating in there flat. I think... Oh, well, this one had a small little burr on it. It's good enough. It's good enough. It's a fucking screw. Okay? It's good enough. All right. Let's finish these. It's not ruined, chat. It's fine. It's a screw. It's a screw. Okay? Relax. Okay. Next. It's fine, chat. It's a screw. It's literally a screw. Okay, coming down. Okay, same thing. We'll leave 1 or 0.1. Okay, final. Okay. Easy. Easy. Last one. Okay. Okay. Same thing, leave 0.1. Let's go to 0. Okay, 0.12 left. Okay, last bit. There it is. Okay, now we're just doing chamfers. So let's change out our tool, and now we just have to go through and chamfer all of them. But I chamfer by feel, so now it doesn't matter as much. Something in there. Okay. I guess in theory we could do all the chamfers basically that same way. Let's see if we have enough clearance with this setup to do the chamfers, and we might not. Oof. Oof. So that's touching. That would be rubbing. So you can back off. Let's say that's touching. So then we could come back. 0.1 is probably enough clearance. Oh, can we? Oh, let's see what we got. Oh, I gotta set my 0. I think we might be able to get the chamfer here. No. I think we can do a 0.5 chamfer. Yeah, 0.5 is all we can do here. Fuck! That doesn't match the others. What do we want to do, chat? Or are we just happy with that? It looks good. That's the 0.5 chamfer. Damn. I'd have to do a little bit more stick out if I want to do a different chamfer. The problem is we did one on all the other chamfers, so I'm afraid these are going to look a little asymmetrical. So let's just see what this looks like. We'll pull it out. To be honest, I kind of wish I did a 0.5 on the bottom, but here it is. So that is the 0.5 up top. We have a 1.0 on the bottom, and then we have a 1.0 for the threading lead-in at the tip of the screw. But I think this is fine. and then we're gonna slot the top. I think we'll just slot straight across. I don't know. Thoughts? Good enough? I kind of wish I did a 0.5 on the bottom, but let's see. It's fine, chat. It's fine. It's fine. It's fine. It's fine. It's fine. It's fine. Okay, it's fine. It's fine. Let's just go and bang those out. And then we'll slot them. And then that's the screws done, I think. Well, it's not. Then we have the hard part. But we're not gonna talk about the hard part yet, chat. Okay? So I didn't save the spindle Z height, so we're gonna have to kind of redo the positioning on this one, but it's okay. Not too big of a deal. Up, in, over, find clearance, set our maximum. There we go. Back it off. Back it off. Give us 0.1 mil. 0.1 mil clearance with crashing. Come on. Good. 0.1, that should clear. Come in. Now we're gonna touch. Touch, and then we're taking 0.5 off here. That's it. That's it, chat. That's easy. See? Was that hard? I don't know why you're making such a fuss about it. Boom. Boom. Okay. Okay. Crushing it. Click. Next. Touch. Give ourselves 0.1. Okay, touch. Touch. Here we go. Woo! Boom. Boom. Bam! Click. 0 that. 0.1 to clear. Clear. Next. Okay. Yeah. Clean. Clean. Clean, chat. Okay. So now we need to slot them. Okay. Ah? Are they looking, chat? Are they looking? Ah? Perfect. Perfect. Yeah, look pretty good. Yeah, the chamfer on the bottom is a little deeper than I want. Because the chamfer kind of interacts a little weird where there's just not a huge lip on these. Not a huge fan of how little lip there is on this, but like, it'll be fine once we have the actual part in there. The holder. But yeah, we'll probably, oh, look at that. That threaded all the way through. Okay. So that's one. Let's see the next one. Because yeah, maybe the threads are now gonna run to the bottom. No, this one's a little tight. Yeah, we'll probably just run the die over these. I think there's probably just a little bit of schmutz on them. Or I just didn't cut them quite enough. But that one's good. That one's tight. So we have two that are tight. But yeah, we can just run the die over them. And we can run the die over those backwards. But those are looking really nice. To be honest, I might just slot them in these. Because that solves the work holding problem. So I might just tighten them into here. Yeah, let's do that. So let me go free up my my die. And we can run the die backwards. And running the die backwards will allow us to reach a slightly deeper depth. Because the die has a little bit of a lead-in, right? It has a little bit of a taper on the first couple threads. And what we can do is by using the die backwards, we can kind of not have that lead-in, I think. We'll see. We're not going to force it. So let's just see if we can run the die up on it. What die holder do we need? This one? Nope. Smaller. Okay. see if we'll be able to feed this by hand. This die isn't fully in here yet. Okay. Just need a little tappy tap. There we go. Okay. I guess I have the die in here forwards. Let's just make sure the die runs all the way up. Okay, there is a tight spot at the end, but it's not much. I mean, I'm grabbing that with my hands, and I don't have much to grab onto here. So the fact that that's going okay makes me feel pretty good. So there we go. Probably remove just a hair of material there, and then cleared up any potential chamfer issues that we had. So I'll do the same on this. Man, that is a clean thread. That feels really smooth. So we definitely erred on tight for these threads, which is kind of intentional. Let's not cross thread this. Let's not cross thread this. We're good. Threading. Same thing. A little bit of resistance at the very end. We'll kind of finish that up. Pull that out. Okay. Next. Yep, same thing. Good. So hopefully these all thread fine once they're done with this step. Otherwise we'll flip it over, do the other side, and if it still doesn't, then we don't really have any option other than maybe removing just a smidgen more material. Okay. Yep, this one's a little tight. Come on. Come on. Come on. That final thread. Okay. All right, we've run them all through the die. So now let's see if they all are able to go to the bottom of these. Come on. 1, all the way to the bottom. 2. Nope, it's tight. Fuck. Really? Let me try a different one. See which one's the problem. Yeah, definitely, that one feels a little crunchy. This one feels a little crunchy. So we have 2 that feel good and 2 that are a little crunchy. Let's see. Wait, this one feels crunchy too. Okay, it might be the threaded holes at this point. Let's see. Nope, that one's crunchy. Okay, these two have everything's felt crunchy. Let's see if this one goes in. Yep, that one bottoms out. Okay, so that's good. Let's try this one. Okay, that one's a little crunchy. A little crunchy. What about this one? A little crunchy. Well, we have 1 match. Or 2 matches now. Oh, wait, this one's not going in now? Really? Which one was working? Okay. We've got 2. Do you still do security for work? Yeah. Oh, 3. 3. Come on. Please give me the 4th one. Ah, it's crunchy. Okay, let's blow it off. Let's blow it off. We're coping. We're coping. A little tight. A little tight. Okay. Let's dye it. Let's do my reverse dye trick. We're not going to force it, just in case the reverse dye trick is bad. Get out of there. Get out of there. Hello? Hello? There it is. Okay. So we'll expose the non-tapered side of the die, and hopefully this isn't a disaster waiting to happen. Okay. Just gotta make sure that this thread's in here. Because if we cross thread it, it will just cut a new thread. That looks like it's in there, but it's tight. But we kind of expect it to be tight. Oh my. I think we're good. I don't think it's cross-threading. Okay. Doesn't look like it's cross-threading, chat. Okay? That's a good sign. Now, we need a way of grabbing this. Chat, we're not cross-threading. What did we say? We said no cross-thread. We said no cross-threading. Oh, come on. Please, God. Okay, I'm gonna pull it out before I finish it, just in case I'm damaging threads. But I don't think I am. I don't know if you can use dyes backwards. I imagine you can. I don't know why you couldn't. Yeah, that looks fine. Okay. Looks fine. We're not cross-threading. Oh my God. Okay. That's it. Okay. 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 Get out of there. Get out of there. Get out of there. Okay. Blow it off. Okay. Now it's gonna go in there real nice. Yep. There we go. Clean. Okay. See the backwards trick. Yeah. And really not much wobble on that. That's a pretty good thread. I'm happy with that. That's a real good thread. We could do the same with the others if the others have issues. But that's kind of what I expected when we're going up against that shoulder. But yeah, that's all the way down. So we have 4 matches now. So let's see what we're doing on weight here. Okay. So they're not cleaned. Let's see, roughly 117.09. 117.10. 116.96. 116.91. That's pretty fucking good. Wow. We got all. Wow. Really? I'm surprised that a threaded thing would have that similar. Wow. Okay. Okay. Okay, so now we just need to, yeah, let's just slot them. I think I'm going to keep them in their mounts. So I'm going to tighten them onto their mounts because it gives a little easier base for me to grab. And then that will be, we'll just one pass, slot them all in a row. Oh, fuck yeah. Oh, those are good threads. I do wish I did a slightly less chamfer on that bottom side, but whatever. That's my only regret for this project. Just trying to tighten them. Tighten them. Okay. Bam. So how do I want to hold these? I think we'll just put them in the row on a vise. I hope the current vise can just hold all of them. Yeah, I think we can just slam those all in the vise. All right. This is probably the scariest operation of the night. This is the one where I think they can actually, we can pretty easily break this end mill. Nobody likes working with with a 2 mil end mill, especially when you're doing slotting. Pretty much the worst case scenario here for milling. Okay. Are we just gonna do 2 at a time? Two at a time? there's a little bit of a nipple on these. They're not sitting perfectly flat. So I'm just gonna put them on some small parallels. Just so we're not hitting on those edges there. And we'll have them facing the same direction. So in theory, we'll get roughly the same angle on these threads, which will just look cool. I have no idea if this vise is trimmed in. I should probably check that quick. Let's do that real fast. And then we just have to find center of these parts. And actually, let me tighten them down a little bit too. Now that they're in the vise, we have a little better grip on them. I can make sure the tops are tight. Topsies are turvy. Yeah, there we go. There we go. Okay, rotated the whole part. Okay. Let's get our 3D taster out. Taste the 3D. God, I hate R8 collets, man. R8 sucks. So I'm just gonna measure off the 2 back points here. Just gonna make sure that we're getting a consistent reading on both of these. Okay. Zero. Go to the other side. And we'll see if we also hit the same 0. Or at least close enough. Whoa. Okay, we're off by a lot. That's a 724. Okay. Okay. Well, we're on a rotary table, so we'll just tram it with the rotary. Fuck it. So I'm gonna get out a indicator. Okay. Okay. Where are my indicators? Let's do there we go. I think this uses a 8 mil. I think it's 8 mil. 8 mil. 8? Yep. Okay. Skadoink. Skadoink. Load up an indicator. This is a 2 micron indicator. And then we'll just sweep this back edge until we have this trammed in. Okay. I wonder if you can read that indicator. Problem is I can't face it off axis. Okay. So let's just go. Let's go to 200. Falling a lot. Yeah. Okay. Where's my hammer? Okay. Okay, we're climbing. Climbing. Sitting nooch. Still climbing a bit there. Falling. Neutral. There we go. There we go. So now when I sweep this, we're staying within, wow, we're like maybe off by, let's say 4 micron. So that's within 4 micron across that whole sweep. Pretty nice on a rotary table, isn't that? Let's use our wiggler for this. I don't want to do the whole stick out again for the taster. Okay, so we just need to find y equals 0. Legs are shaking. Let's do more stick out. And I'm just gonna go between the 2 vice jaws here. I think, depending on how far I can get in here. I think we should be good. Okay. So I'm watching for this to stop wiggling. And then it'll kick off to the side. And that's my 0. There it is. That's Y0. And then we'll go back to the other side. And same thing here. It'll slow down on its wiggling. Slowing down. Once I make contact. There it is, contact. Kicked off. So now we half Y, and now we have Y equals 0 between those 2 points. So this is kind of the old school way of centering. This is a center finder. Some people call it a wiggler, I think. I like it because it just has less tool stick out compared to that taster that has like a really big stack up. Okay, so now we're gonna load up the 2 mil end mill. Let's just see. It has a 3 millimeter shank. So even though it's a 2 mil, it has a 3 mil shank. I think I can just do that directly in an R8 collet. Because I think I can go down to a 3 mil here. So we'll load this right up in. And then we need to figure out what our feeds and speeds are going to be. Normally I run these end mills at 65 meters a minute. It's such a tiny end mill. Oh my god. Let's try and get you in there, chat, so you can see this ridiculous end mill. Okay. So we might just snap this fucking end mill. Like, this is a hard cut. These end mills suck. Slotting sucks. So first, y equals 0. Okay, that's all that matters. And we're gonna go, we wanna go 3 mil deep. So I'm touching off here. 9.94, so this is our touch off point. We're gonna 0 Z. And now we can drop down on the knee. And we have our 0 depth. I think we might do half a mil. So I'm gonna do 30,000 millimeters a minute. Pi times 2, divide that down. It wants 4,700 RPM. And then we have 4 flutes. And I wanna do let's do 0.02 per tooth. Let's do 0.015. 15 micron per tooth. Man, even that I don't want to do. Let's do 0.01, which is 190 millimeters a minute for feed, which is going to be this. This. Oh, that's so scary, chat. That's going so fast. Look how fast that is. Fuck. Okay. Not freaking out. It is slotting, but I said 30,000, 190. I mean, that's pretty much as little as I can cut. Oh, God. Okay. Let's get some coolant in here. I think we're gonna go half a mil deep. Okay. Go. I need to get a shorter coolant hose. I got the long one because I'm like, oh, long is just better than short. But the problem is it's kind of hard to get precisely set up. Okay. So we're gonna do, oh my. We're gonna do half a mil deep. That's half a mil deep. Oh my, and we have 190 set up. Holy shit, I don't like this. Okay, quill feed is off. So we're going to 4,800 RPM. RPM. Monka's in the chat. And in theory, I just ram this into it and it's not gonna just break and explode. I think it's just gonna snap the second it touches. I hate this. I hate this. I hate this so much. I hate this! Woo! Woo! Wow. Okay. We're good. We're good. We're good. Oh my god. Oh, that's terrifying, chat. Okay, let's go down. I'm gonna do the same pass in the same direction because it worked, right? That pass worked. We're gonna do the same fucking thing. We're gonna go another 0.5 deep, so this is gonna be 1 mil deep total. Now keep in mind as we get deeper, it's harder and harder and harder to evict these chips. So even though the first ones went well, doesn't mean subsequent ones will. So we're 1 mil deep, we're on center, we're at RPM, here we go. Oh, I hate it. I hate this so much. Okay. Oh, it's so scary. I think I'm gonna grab my coolant line here. No. Okay, we're good. Oh. Oh, I hate that. Oh, I hate that so much. Okay, we're 1 mil deep. Okay, 1.5. Oh, God, that's terrifying. I saw the drop of water shoot off, so I thought it was fucking cooked. Oh. Okay. I think I can just go back. I'm not scared, chat. I'm not scared. We can go back. Here, we're going back at 2. This does have a different coolant exposure. The end mill still exists, so that's good. Oh my god, I hate this. I hate this so much. Oh. Okay, 2.5. Oh. Oh. Oh, I hate this. But we're cooking, chat. We're cooking. $4,800 RPM. All right, 3 mil. This is our final. 3 mil. Woo! Okay, that one's probably done. This is terrifying. Good. The whole end mill is there, chat. Oh, man. Bearings? Bearings don't care. Bearings are happy, man. Whew. Scary. Terrifying. Oh yeah. Look at those bad boys. Look at those bad boys. Oh, fuck yeah. Those turned out sick. A little deeper than I think I wanted to go, but it's fine. Yeah, hopefully that doesn't have any strength issues. I don't think it will. I think it's fine. So, I'm not gonna chamfer those. I'll probably just finish those on the machine. Okay. Those look pretty good. That was pretty pog. That was very pog, chat. Okay, 2 more. See, I wasn't worried at all. Why were you guys so worried? Okay, we're good. Good. Okay, same thing. Same thing, chat. Let's find 0. That's 0. 0Z. Gonna go down. Gonna go over. 0.5, chat. 0.5. E-stop reset. Coolant is flowing. Y is locked. Z is at 0.5. We're ready. We're ready. Oh my god, I hate that. I hate that so much. Oh. Oh. Okay. 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 Next one. I can hear it. I don't like it. Go, get out of there. Okay. 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 1 mil. The parts are probably usable now? Well, at 1 mil deep, they're probably usable. Beauty. 1.5. Whew. This is easy. I'm not scared at all. Okay, 1.5, these are probably actually usable as screws if the end mill were to break right now. 2 mil. Dude, we're so good. We're so fucking good, chat. Beauty. God, 4,800 RPM is just insane, man. That's terrifying. It's so scary. $2.5. And here's 3. Here's 3. Man, that's deep. That's in there. It broke. Shit. I wonder what happened. I wonder what happened. Like, I wonder if it got hot? I don't think so. I mean, the snap there, to be honest, it probably just hit a hard pocket. So let's see, let's recover this. Damn. Looks like it'll come out. Okay. Yeah, I just sheared. The cutting edges are in great shape. So the cutting edges are great. It just snapped. So probably hit a hard spot. I mean, I am running it deep there. That is the deepest part of the cut. Fuck. That sucks. That's fine. Luckily, it looks like I was able to get that whole piece out. So we're just gonna have to come back in. I do want to finish it up. I've got more twos. The twos I have are uncoated. These are coated. So I think the next twos I might just be a little more careful, and I might go to I might just really crawl up on this. But yeah, I don't know if the part got loose or if it vibrated. I'm not seeing any carbide in there, so I think we can come in here and do another pass. Clean it up. That sucks. Okay. Cutting tools. Let's see. I don't use twos often. Okay, I've got a 2.0 length of cut, 6.3, a 3.0 shank. So this is equivalent, but it's uncoated. The other one was TICN. This one is uncoated. So I want a little less speed. So let's see. Damn. That sucks. Okay. So I don't know what snapping means. There's kind of like guides and rules to like when things happen, what roughly it means, like what you should change. I think there's just too much force. We were doing too strong of a cut. Okay, 0, 0. Okay. Next, let's find Y0. Okay, Y is at 0. Oh, I didn't mean to lift this up. That was kind of a mistake here, to be honest. Okay, let's go back, touch back off. So I want that to touch. I want to clamp that, zero my Z, go down on the knee. Now my quill's locked. Okay, what are we gonna change? I mean, it could be that we're cutting too slow. I think we're just gonna not go as deep is what we're gonna do. So we were at 2.5, right? We were at 2.5. So let's just go in there with 2.5. Let's just make sure we can exist in there. Come on, coolant. But yeah, maybe it got hot and it grabbed. Maybe it was just too far. Maybe one of the teeth chipped. Okay, so this is 2.5. Pretty much same parameters. Let's just see what happens. Since we switched end mills, this one could be a little bit wider, so I just want to make sure we can get through here. I'm a little scared here. There might be a small piece of carbide in here, which could really get this mad where it broke before. And we came out with the whole end mill. So let's go to 2.65. So now we're doing a cut just extremely small. And I'm just making sure we can kind of get past that shoulder because we now have a work hardened edge in there. And I'm just really scared of that work hardened edge. I do think I'm running a little slow. But we're just gonna finish it like this, chat. So we'll go to 75, 275. This is 0.1 mil depth of cut. But yeah, maybe the teeth just filled up. Like maybe it just clogged up with chips and I just didn't have good coolant eviction in there. Or good chip eviction and you just get fucked. It packs up. You just no longer have a cutter. Okay, we're gonna go 2.85. We're good. Yeah, we're really babying it now. Okay, we're gonna go 2.97. And then I'm gonna go to like 3.02. Just so there might be a little bit of a gouge or a bigger hole where that tool broke before. So I'm just gonna slightly overshoot because we were at 3 when we were doing that cut that failed. So just to try and clean it up, we'll go to 3.02. And that hopefully will clean up anything. So that's now a new fresh bottom. Should be fresh that whole pass now. Really light cut, so we should be safe now. All right, we're good. Well, we're not done yet. There we are. Come on! And we're good. The whole end mill is still there. Okay. Let's get this end mill out first, because it's just fragile. I mean, it's basically a piece of glass, right? So, and yeah, I mean, that's in
literally perfect shape. Did I chip a tooth? I don't think so. Yeah, it looks perfect. Okay, we'll put that back away. See, that wasn't hard at all, chat. I don't know why you guys are so scared. Fraidy cats. Okay. Okay, that is done. Bam. Okay, come on. Come on out. Yep, I can still see a little bit where that one broke off, but it's fine. There we go. So now we've got those all slotted up. And now we can start seeing how our weights are. And then we gotta figure out how we wanna adjust the weights based on how much of a weight difference we have. So we might just sand them down a bit. It really depends what readings we get on the scales here. So now we want to actually check the individual screws and the individual pieces. So let's first, yeah, those look good. Those look good. And then how does the screwdriver go? Oh yeah. Oh yeah, nice and deep, really good engagement on the screwdriver. Okay. So, yep, just a little bit of marring where that one piece broke off. Okay. Those edges are sharp. We might want to deburr those. So we really need to just clean these up. So we can get accurate weights on them. So, let's see. Let's see. Okay. Nobody's listening. Oh, she's tight. She's tight. Okay, let me grab another pliers. I don't want to damage the thread yet, or not the thread, the slot. Okay. 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 One more. Oh, whoa.
So I need to figure out where I'm going to want to remove material to balance these. So first, I'm going to clear the main boys. Okay. I'll clean these off. Really just trying to dry these. Okay. So this one is 9281. $92.81. $92.82. $92.82. $92.83. Yeah, so we're within 20 milligrams on all of these. So that is very, very good. Now we have to do the screws. These ones I expect to vary a lot because we haven't optimized them yet. The other ones have been balanced. These have not. So we have a 2291. A 2301. $23.02. Yeah. $22.86. Okay, so we have to remove just a tiny amount. God, what even is... It's a Claude problem. I have 4 parts made out of 316. 22.91 grams, 23.01 grams, 23.02 grams, 22.86 grams. I want to get them all equal mass. How much material do I have to remove? There are 2 cylindrical parts, 8 millimeter diam part and a 25 millimeter diam part. If you want to give me linear removal from either of those. Okay, 0.16 grams removal for the 8 millimeter diameter part. I need to remove like 0.4 mil. And for the 25, I need to remove like a couple thou. I think we're just gonna sand the top. I think is what we're gonna do. So let me just get some sandpaper out, and I think we're just gonna sand that top part. How does that sound, chat? Yep. What kind of grit do we need? 320? I think 320 might be fine. How to pay. Okay. So let's double check the 2286. 2286, perfect. 2302. Pretty good finish on those. You can see how close to flat that is. So 2301. '23. That's pretty. Look at that. Oh, fuck yeah. 2297. I'm pretty happy with this removal rate. I feel like we have really good control. $22.94. $22.92. $22.90. Sandpaper's pretty clogged. $22.89. $22.88. This is great. $22.87. $22.86. Done. Let's double check. $22.86. $22.85. That's okay. This one still needs to be cleaned up. So I don't want to go all the way down. Okay, let's grab a new sheet. We could probably clean this one, but I'm not going to. Okay, let's double check. 2286. 2286, 85. 2291. 2288. 2287. 2286. 2301. 2296. 2294. 2291. 89. 88. What are you making? I'm making some screws for a fly cutter. These hold the insert holders. 2286, 87. Let's go a little more on this one. 2286. 'I'm gonna go a little more on the original. Just to kind of clean up any burrs. There we go, 85. So now the target is 85. One more. $22.85. $22.85. 86. A little more on this one. $85. Okay, $22.85. $22.85. 2285. 2285. Fuck yeah. Fuck yeah. Fuck yeah. Okay, let's grab our air. Just so I can blow them off. Really make sure they're dry, don't have any dust on them. $22.86. It got heavier as I blew it off. Let me blow this off too. $22.85. $22.85. $22.85. $22.83. I knew that one had dust in it. God damn it. It's ruined. I'm cleaning the threads and then we'll do a final pass. Unperfect. I know, we fucked it. Just making sure the threads are clean. Okay. 85. So it's this one that's low now. Nope. 2285. 2285. 2285. 2285. Okay, let's put all of them. What's that? 9141? 91.40 divided by 9141. Divided by 4. 228525 should be the average. 2285. Okay, we can probably stop measuring them, but it's good. 2285. That's so sick, chat. Oh, it's beautiful. Okay. This one maybe can have a little removed. It's good now. There we go. Okay. Okay. So these are all 2285 now. That is so sick. So we'll say 22.85. Okay, we'll do the same to the other ones, I guess. Because that went really well. Let's first make sure they're all clean. 9281. 9281. Okay, we don't have another 9281. 9283. 9282. Okay. $92.81. $92.81. $92.82. $92.82. $92.81. 83. $83 still. $92.81. Yeah. There we go. 92.81. 92.81. 92.81. 92.81. Fuck yeah! Okay. Now we gotta join them. And yeah, you can use any with any, which is kind of the whole design. I didn't want to pair them. I didn't want to make matched pairs, because that would have sucked. Hello? Hello? Okay, that one's incompatible. Hello? Okay, one. Okay, that one's tight in that one. Done. Okay, that one's a little tight in that one. You gotta find the right match. Okay. Fuck. Might have to touch these up on the threads. And do the backwards thread like I did. Because, yeah, these are just a little tight. I think I'm going to backwards thread all of these, and then we're going to have to rebalance them, maybe. Kind of depends how much material comes off. Because I really don't want them to really only fit in one holder. All that was for not chat. I wonder how much this will change them. Okay. That's one. Okay, complete. Okay. Oh, this one's tight. We cross-threading? We cross-threading, chat? No? Rip our balance. Rip our fucking balance, chat. Okay. Yeah, I wonder if I need to tighten the die a bit. Like the die has that set screw. I don't really know how it works. I don't know if I'm supposed to adjust that to like get different thread fitments, but whatever. Okay. Okay, we're good. Beauty. Okay. 0.1 gram change? Yeah, I have 0.01 gram change. I have no idea how much of an effect this will have. One of them definitely cut a chip. I don't know if these ones are really cutting. This one's not cutting, so that's good. Wait. Okay, this one's cutting a lot. We cross-threading? No? Okay. Okay, I wonder how much that changed it. Some of these I think definitely had a chip removed. Okay. 2285. 84. 84. 83. Okay, let's just make sure we repro. 85, 84, or 83, 84, yep. 84, and then this one's 83. Okay, very little change. So we'll go down to 83 now. '84. '83. Okay, that one says 83 now. I think it's on the fence, so we'll take a small amount off. 83. Welcome back, Penguin Operator. '83. '83. '83. '83. Okay. Last pass. 83. 83. 83. 83. Okay. Done. Done. Done, 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 done. Okay, and then these were done too, right? 82. I think they're supposed to be 81. 82. Maybe gravity went up a little bit. 81. Shit. 81. Okay. Okay. 81. 81. Okay. Okay. Now we can connect them all. All right? Isn't this riveting, chat? Definitely a little tight. A little tight. I don't like that. Why is that still tight? It probably just needs to go in and out a couple times. That's fine. Yeah. They'll settle. They'll settle. I think we're good now. Good. Get in there. Get in there. I think this one has a fucked thread, not the screw. Once it's in there, it's good. It's just got a rough, it probably has a burr on one of the first threads. Bam. Okay. Full assembly. Full assembly, chat. 115.64. 11564. 11565. 11564. So you got one heavy one. Oh, there it is. It's 64 now. Let's see what the average is. $462.57 divided by 4. 115.64. 115.64.25. Yeah, so I think 1 is on the high end. I mean, that's beautiful, chat. You can't... Oh, it's beautiful. Oh. Okay, let's go and see. Let's clean up the mill a bit. Okay. Fuck, that's loud. Okay. So. Let's see how our fly cutter works. Okay. That's heavy. Okay. Okay, we'll wait for the compressor. I'm gonna drop this a little bit. Let's go down to like here. Oh, let's make sure it's in. Yeah, that's in. Okay. Pop, pop, pop. Scoop, scoop, scoop. Okay. Fly cutter set up. Okay, so the theory is that this fly cutter will hopefully be nice and balanced, and I gotta wait for the compressor to kick off, because I gotta be able to hear it. But hopefully it's running nice and balanced, because it was before. Okay. All right, so really we're just looking for vibration and shaking here, and hopefully there's not much. So we're gonna start with 500 RPM, which is already quite fast. Okay, doesn't like that. Once it gets started, it's good. It's kind of the slow start. So everything's smooth, nicely balanced. This is at 600 RPM. So let's get you the RPM dial. Okay, we're at 600. 600 looks good. And I'm just looking for vibrations or issues. They're at 1,000. That's happy. I'm gonna move this a little more out of the way. We're gonna make sure that we're not dropping our spindle either. 1,000 seems quite happy. And then before we continue, I just want to make sure that this is tightened down. Pretty sure it should be. But just in case, I can't remember if I've tightened this recently. Because if I haven't, that's scary. So let's first make sure that's tight before we continue. Is that metric or standard? I forget. I think it's standard. I think it's a 3/8. I think it's 3/8. Let me double check. Yeah, 3/8. Okay. She's tight. Okay. Okay, back we go. Here we go. 1,000's good. 1,500. It's happy. $2,000 is happy. You can hear the wind coming off of the holes, right? $2,500, buttery. I don't really want to go past there. There should really be no risk of anything, but that's probably as fast as I'll run it. Because ultimately, when you're taking this big of a cut, you don't really need that much. So there we go. So yeah, up to 2,500, no problem with the disc. So that is buttery. So next we're gonna go up and we're gonna add our inserts, right? We're not actually putting our inserts in here for a cut. We're just loading these in just to see how our balance goes. And also, we don't even know if these go in here, which they should, hopefully, because we designed them to, but that should slot in, hit the shoulder, it's recessed, which means we'll be clamping, because we know that can go flush. Where's the thread? I think I might have chamfered these after threading them. I think I need to chase these with okay, and then we'll face the inserts outwards as we would if we were actually cutting, and then we'll tighten down our big screw. Okay, so we're gonna go back gear, we're gonna go low gear, switch, and now we're running a lot lower speeds. I just want to show you what it's like when we just have one insert in here. So we're only running 120 RPM. That's good. Definitely a little vibration already. Okay. So we're actually going to go to high gear now. I didn't know how bad that vibration was going to be. So we'll go into high gear now. Yeah. Massive vibration. You can't feel it? I don't know. You might be able to see it. Like, it's kind of scary. Let's try and be a little more scientific about it. I think I have Fightbox. Let me see. Fightbox, acceleration without G. So we'll just set it on the mill. Or set it somewhere. I think just setting it on the mill table is good. Okay, record that. Yeah. Here we go, chat. So this is at 500 RPM. Right. And we'll turn it off. So yeah, pretty bad. Pretty bad. So, the dream is that we've designed this, and then I'll show you, I'll take this one insert off so you can see that with the same setup. So I'll remove this one insert. Okay, so the one insert is now removed. So now it's just the raw disc, same RPM setting, and I'm just gonna clear the data, start a new log. So here we go, starting it up. And there you go. I don't know what the absolute scale was before, to be honest. I probably shouldn't have cleared it. But yeah, it's like pretty buttery smooth, I would say. This is under 0.05. I don't know what it was before. Anyone know what it was absolutes before? But yeah, there's a difference. Okay. So then the dream would be that we should be able to load up all 4 of these, and we should be fine. So we're gonna throw them on and see what happens. So one's loaded up. But yeah, really the only time you'd be using this fast is with aluminum, right? Anything else, these cutting speeds would be way too fast. But with aluminum, the cutting speeds are literally like uncapped, effectively. So if you want to get a good finish on aluminum, you need to cut really fast. And so even with this like 12-inch disc, You actually want, I think it was like 1500 or 2K RPM that I wanted to be able to run this at. And the plans are for precision, I'll probably actually only run one cutter, but I can't run one cutter. You saw how unbalanced that is. So instead what I'll do is I'll run all 4 cutters mounted, and I'll have inserts and their insert screws, but I'll shim one of them like 1 thou out. So one of them will be the one that's actually cutting, and the other 4 will basically be there only to balance, or the other 3. Okay, so those look good. Let's make sure they're tight. And then hopefully the vibration is gone. Now, we do have some, like, these are technically able to, like, grab some wind. That could affect things. But hopefully it doesn't. Okay. And I'm trying to make sure they're all kind of aiming the same direction. Okay. Tight. 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 Okay, we're good. Okay, we're gonna go to min speed, which would be about 500 RPM. And let's see what we got. It's good. It's good. It's good at 500. It's good at 800. It's totally fine. Yeah, no vibration at all. None. That's 2K. I don't really want to push it, so we'll be happy with that. I mean, I don't think there's any risk of anything really going wrong here. I don't know if, like, depending on a vibration mode, maybe these could unthread themselves. I don't think they will, but yeah, that's what we got. So there you go. That was the stream. I think I'm happy with that. Now I just have to really load them up with inserts and actually make some cuts. So that actually turned out pretty sick. I'm happy with that. And it worked exactly as planned. That it just basically was the same as the raw disc. Because, yeah, the one cutter is terrifying. It's fucking scary. So, but all of them, totally good. All right, chat. Thanks for stopping by. See ya. Well, I can't end. How do I end the stream? Fuck. Do I gotta go inside? S'mores is gonna want pets. Shit. Okay. I gotta pump my hands because they're gross. Okay. Oh, that's pretty successful. Huh? See? Look at that. Yeah, fuck you, Moose. Bitch. You don't even show up to my streams. When was the last stream you even showed up to? You haven't been to any of my streams this year. Cringo. That's what we call that. We call that cringo. Cringo for cringe. I was sleeping. You keep streaming when I'm in bed. Oh. Interesting. Sounds like one of us can fix that. The other one can't. So, all right. Well, that was the stream. Thanks for stopping by. Hope you had fun. Zip, zip, bibbidi bip.